Hello, everyone, and welcome to the Builders Workshop. We got Joe here today as our special guest. We got
Hey, everybody.
Benefactor here.
What's going on, everybody?
Guys, we're ready to rock and roll on this thing, man. We did a video a little while. I transcribed it, or I should say the AI did for me. And it was really cool, really informative. We're going to play a little bit of that today, but we're going to be talking about the Byfield-Brown effect and what the actual true answer to that was. There's a lot of people that don't understand it. They still think it's an ion lifter. They think it's ion wind, and it couldn't be further from the truth on what it is. So with that said, guys, what do you think?
Let's get into it.
Right on. Okay. So the way this sets up, guys, we're going to do a little bit of the video, and then we're going to stop it and commentate. So
sounds good.
Also agree with me real quick.
Volnpod's 20 event number 1. Also to be found at the T. Townsend Brown family website. The scientist and layman alike encounter a primary difficulty in understanding the Byfield-Brown effect and its relation to the solution of the flying saucer mystery. A proper interpretation of this theory is prevented because both scientist and layman are conditioned to think in electromagnetic concepts, whereas the Byfield-Brown effect relates to electrogravitation. Their lack of awareness is justifiable, however, because the data on electrogravitation, inasmuch as it is comparatively recent and unpublished development, has limited availability and circulation. Townsend Brown, the discoverer of electrogravitational coupling, is the only known experimental scientist in this new area of scientific development as of this writing. Thus, anyone wanting to understand electrogravitation and its applications to astronautics must dismiss the principles of electromagnetics in order to grasp the essentially different principles of electrogravitation.
Okay, let's stop right there for a minute. They just told you electromagnetism is not it. So that means static electricity. That also means traditional magnetism as you know it. As we all know, everything's made up in volts and amps, and depending on how many volts you have in it, if it's really high, you get static electricity. If it's really low, you get high magnetism. It's all the same effect. They just said that it does not hinge on that alone. So you will get static electricity, and they'll identify that in here.
Electrogravitational effects do not obey the known principles of electromagnetism. Electrogravitation must be understood as an entirely new field of scientific investigation and technical development. The most efficient method of affecting an understanding of electrogravitation is to review the evolutionary development of electromagnetism. From the smallest atom to the largest galaxy, the universe operates on three basic forces, namely electricity, magnetism, and gravitation. These forces can be represented as follows. Figure 1. Three forces. Taken separately, these forces are of no real practical use. Electricity by itself is static electricity and therefore functionless. It will make your hair stand on end, but that is about all. Magnetism by itself has very few practical applications aside from the magnetic compass, and gravity simply keeps objects and people pinned to the earth. However, when they are used to work in combination with each other, almost endless technical applications come into being. Currently, our total electrical development is based on the coupling of electricity with magnetism, which provides the basis for the countless uses we make of electricity in modern societies. Faraday conducted the first productive empirical experiment with electromagnetism around 1830, and Maxwell did the basic theoretical work in 1865. The application of electromagnetism to microscopic and submicroscopic particles was accomplished by Max Planck's work in quantum physics about 1890. And then in 1905, Einstein came forward with relativity, which dealt with gravitation as applied to celestial bodies and universal mechanics. It is principally out of the work of these four great scientists that our electrical developments, ranging from the simple light bulb to the complexities of nuclear physics, have emerged.
Okay, we'll pause it right there. Okay. So they clearly stated what it was. I mean, the only thing in question was what was the gravitation. So they said static electricity. We understood that one already. Gravitation. And what was the last one, Joe?
It was gravitation, electromagnetism, and then antigravitics. Now, I mean, once you start dissecting that, you know, what it really comes down to is density. You know, the electromagnetism effects are higher density and have flow, whereas the static is lower density with no definite flow. And then you have matter and gravitics that has the highest density. So all these higher density materials are going to have an inherent attraction to one another, which is the gravitics end of things. But you know where it becomes you know, relevant and interesting with antigravitics and static, like you said, low density charge, is how you achieve that, and that has to do with containment and separation of those charges. So containing the lower density static charges and having it break the locality of the gravitic fields that are surrounding it, because again, you know, statics and different forms of electromagnetism separate of it, they're only manifest in the energy in the presence of matter. So wherever there's the presence of matter, you're also going to have some type of gravitic force acting as well. So all the three things are connected, but generally same environmentally. It's separating them into three separate parts, okay, that ultimately allows for you to break the gravitic you know, attractions.
So let me just be clear about what the answer is here. We have static electricity. You have to have a field that holds in static electricity. Negative radiant energy holds it in. Now, that's the only thing I've ever found to hold in static electricity. It is in the air that you can make a field bubble out of. The last thing is the magnets. We constantly, in every single project that I've ever seen to do with anti-gravity, has some form of rotational magnet on it. Generally, this is your basis for your ground line. It's usually connected to the same exact thing. Anytime you see a grounding part in the system, it has magnets rotating on it. It's just a simple way that every project works. Everybody's learned it that way. Those are the three fundamental forces. When I say negative radiant energy, Tesla described his Tesla coil when he first built it as a radiant energy. It blew through everything, including the lead. So it would get everything hot in the room. So he can change the temperature of a room. When you say negative radiant energy, you're meaning the cold side that he developed through his hairpin circuit. It basically was the other side of his radiant energy. What's so interesting is there is a temperature differential between the static and the negative radiant energy. That's the point that everybody needs to start to understand. You see, that cold field's holding in the hot field, just like on a cold day outside. When there's snow out there, you open your window in your warm house, you let it in, right? But it also holds it out as long as the field on the inside is there. So when you say static electricity, even though it's mostly voltage, there is amps in it. So there is heat present. And
That makes sense.
You've got to remember, this is low charge fields. This is not high charge fields. We're not in the positive portion, so we're not forcing electricity through everything. These are low charge. So everything has a low amount of energy going in, generally 10 to 12 volts in order to start a project like that, in order to see effects. So I just want to throw that out there so everybody understood. This is something that's already done, guys. This isn't something that's debating in my head anyway. I've already created the field. I've already got one to hold into the other, and I can push, static electricity across the room with that negative radiant energy very easily.
Now, I want to jump the gun just a little bit before you put it back on, because I think that bringing it up now slightly will, when it's said, it'll bring more context to it anyway. They're going to go into the charge separation aspect of this. Okay, and one of the main things that they're going to bring up is any sort of materials K value. And what you're going to realize is that oxides generally have extremely high K values. Now, if you go back into a lot of the discussions that Nathan and I have had previously, why is it that this K value for the oxides would be so high and lend itself well to the charge separation? And it has to do with hydrogen depletion and play right back into the role of matter density. So it just one kind of tidbit that I wanted to throw in there now. So when it's said, I mean, that context is at least there,
Well, not just that, you have to look at the structure of an item. Like if you mesh it, basket weave it,
Mm-hmm.
and it comes across that way, then the strength of it's so much heavier. So they talked about it in what was it? The Asian lady in the Bedini videos when he did that big series. She was talking about it. It's the cross thing. So even if you look at simple paper is a non-conductor, but when it's statically charged, it is a semiconductor. So energy will pass right over it. It'll make scales drop that weight or push weight upon the scale very easily if you do it right. And you could do that with, 2 flybacks in series. That's real simple. It takes out most of the amps, keeps it in very high volts, makes a great static charge. You don't need to go to the effort of Van de Graaff. That's way too much power. That's super saturation to a field where you're looking for a minute amount at a time. You're not looking to overthrow it, because what happens is in these fields, if you push too much in there once, it flows to the other side, and then boom, it starts shooting across the room.
Right. So when you get the whole point of it goes right back to what I was saying earlier, which is you want a contained but low density field without the flow elements of it going on. Once you start overcharging it, then it wants to leave, because the distance differentials become greater and greater. So it could start having electromagnetic effects under those circumstances, the higher density it becomes, and have a greater outreach to matter in order for those types of effects to manifest. So
it'll field flip on you. What'll happen is you'll get so much energy and heat going into your statics that it starts to become magnetism, like you're saying, right?
Then that's exactly what I'm saying, right?
It'll take the negative radiant energy and turn it into the positive radiant energy and blow the whole system out. So it'll become completely useless because you haven't built up enough field on the outside of the negative radiant energy in order to hold it in. It's all simply putting it together in the right amounts of energy. And then you have to create cavitation.
You have to flip it at the right time, or you don't want to flip it at all?
You don't want to flip it. You want to create cavitation. That bubble is your anti-gravity bubble. That's what Townsend Brown's trying to tell you in this whole thing. That bubble is critical. If you don't have it, you do not get anti-gravity.
Yeah, and when we touched on this before the cast, that's exactly what we were saying too. This is cavitation. It's basically creating a vacuum to then fill it with something else, and then have something holding it in that creates the differential with its environmental factors. That is the fact that breaks locality. And it's that breaking of locality that ultimately allows for whatever's inside that field to basically not be necessarily affected by the electromagnetism or gravitic effects of the outside environment that it's in.
That's exactly what's going on.
Yep.
So that's, by the way, that's why I'm doing the experiment I have, because it's all about cavitation. It is literally about that. So let's listen to a little bit more. Some interesting facts that come up, by the way. And if you haven't watched the Linderman thing, it's extremely important that you listen to that and how he describes how the Tesla coil works, because it's very, very much needed in understanding this a little bit, but we'll continue on. And there's some strange effects that goes on with the hairpin circuit that fall right in line with what this is talking about.
Classmate of Einstein in Switzerland, suggested to his protege, Townsend Brown, certain experiments which led to the discovery of the Biefeld-Brown effect, and ultimately to the electrogravitational energy spectrum. In actuality, it was Brown who first observed the effect and brought it to the attention of Dr. Biefeld, who suggest further experiments to determine the origin of and enhance the effect. Juniper. Biefeld wondered if an electrical condenser hung by a thread would have a tendency to move when it was given a heavy electrical charge. Townsend Brown provided the answer. There is such a tendency. After 28 years of investigation by Brown into the coupling effect between electricity and gravitation, it was found that for each electromagnetic phenomenon there exists an electrogravitational analog. This means, from the technical and commercial viewpoint, potentialities for future development and exploitation are as great or greater than the present electrical industry. When one considers that electromagnetism is basic to the telephone, telegraph, radio, television, radar, electric generators and motors, power production and distribution, and is an indispensable adjunct to transportation of all kinds, one can see that the possibility of a parallel but different development in electrogravitation has almost unlimited prospects. The initial experiments conducted by Townsend Brown concerning the behavior of a condenser when charged with electricity had the characteristic of simplicity which has marked most other great scientific advancements. The first startling revelation was that if placed in free suspension with the poles horizontal, the condenser, when charged, exhibited a forward thrust toward the positive poles. A reversal of polarity caused a reversal of the direction of thrust. The experiment was set up as follows. Figure 2, Biefeld-Brown effect. The anti-gravity effect of vertical thrust is demonstrated by balancing a condenser on a beam balance and then charging it. After charging, if the positive pole is pointed upward, the condenser moves up. If the charge is reversed and the positive pole pointed downward, the condenser thrusts down. The experiment is conducted as shown here. Figure 3, balance. Experiment. These two simple experiments demonstrate what is now known as the Biefeld-Brown effect. It is the first and, to the best of our knowledge, the only method of affecting a gravitational field by electrical means.
Okay, hang on real quick. This is where people get confused with ion wind. This is not ion wind. You can pick up weight in an ion lifter. It is no longer ion wind. Ion wind runs at 2.4 meters per second. It is not strong enough. It will not push this thing up. You can multiply it by different levels of it in order to get it to go higher, but you're not going to do it on a single craft with a single lift. You'd have to take 20,000 volts in positive voltage on a voltage multiplier with an AC flyback in order to get the lift and be able to lift something else with it. No matter how many grams that is, that's the same effect that you have to do. You have to pull that field, just like you said. It's pulling it up. It is not pushing it up. It's pulling. There's a big difference in that. And then I think most people, when they start to get into their static electricity experiments, are going to find this effect because it'll show up every once in a while, but they'll not know what it is. And then once you know what it is, and you know how much more powerful it is, you're going to switch all of your experimentation from the simple ion wind to something else. And you're going to find it in that gravitation right there. It's a known experiment. I have examples of it, and it'll work.
Yeah, I mean, I tend to agree. I mean, the having an ionic thruster, terrestrial, and in the atmosphere for any kind of Earth purpose, which is where gravitics is mostly concerned, right? It would be the most inefficient way to go about it because of the types of power levels that you would need to create it would just be dwarfed by that of conventional boom tech shit, like any sort of rocket's going to outperform that day in, day out, both for payload, speed, the whole 9 yards in atmosphere. I mean, In space, it may be obviously a different story, but then I think you run into and contend with the greater issues of, the fabric of time and space itself. At that point, if you want to achieve the higher degrees of, space transport and such. But, for purposes of what we're talking about, it's novel at best. It really has to do more with what you're kind of preaching and saying right now, which is all the charge separation and just making sure that that you're able to play one field off the other in order to get some sort of propulsion.
Yeah, anytime I've ever seen those ionic devices, they're all made out of real light materials like tin foil or very, very light plastic frame. So they're not very heavy at all.
Well, it's made out of balsa wood mostly. Balsa wood, tin foil, wire on the top. And the thing is, when you get to the point where you can just, instead of leaving the hole in the center, you can make it a flat top and you get it to lift. If you can put like a little bit of weight on it, you get it to lift. You're starting to see a whole different thing. It shows up when you put it on the scale. Every once in a while, as it's normally pushed, the charges, the smaller one always follows the bigger one. But every once in a while, you'll get an opposite effect. And that's the one you're looking for. That big one has to follow that small one. So therefore, it's going to get lighter on your scale. If you're getting the other way around, when the small one pushes into the big one, you got it backwards. That's more static electricity than anything. So it's just an opposite reaction that you're looking for. That one little thing that happens every once in a while, that's what you want to amplify.
Interesting. Well, that's an easy way of putting it.
That's easy to say. It's hard to pull off for a lot of people because
easy for me to understand at least.
Yeah. I mean, look, your wire is like, so let's just put it this way. Your lifter wire is probably this far off, and you got this little triangle lifter like this. And it's got a hole in the center and goes down the side. Anyway, when you get it to like this big and maybe this wide right here, and you can leave it flat, you could put it down on the sides and it doesn't matter. And your wire is this far off of it, and you're putting 20 kV in there, man, and you're not sparking over and it's pulling up extra weight, you've got it. I have only seen one person ever pull it off successfully, consistently. So I'll see if I can.
The math equation, just like everything else at that point. The distance, the gauge, the input, like it's got to be in that sweet spot in order for it not to arc over. It's got to be, and it's got to not be too low or too far, and to have the proper field density that's going on inside of it. And it has everything to do with the spacing and the input. It's sort of the deal.
Once you find it, that's right.
Yeah, it's a tolerance is what it is. You got to be within the tolerance. That's
why we, in that gravity flyer experiment, it's field flipping. You're simply looking to flip the field. Once you flip the field, pulls right up. That's what they're looking for in there. So we'll play some more. I'll look for that other video while I'm playing it.
The intensity of the effects is determined by 5 factors, which are 1. The separation of the plates of the condenser. The closer the plates, the greater the effect. 2. The ability of the material between the plates to store the electrical energy in the form of elastic stress. A measure of this ability is called the K of the material. The higher the K, the greater the Biefeld-Brown effect. 3. The area of the plates. The greater the area, giving the greater effect. 4. The voltage difference between the plates. More voltage, more effect. 5. The mass of the material between the plates. The greater the mass, atomic mass, the greater the effect. It is this 5th point which is inexplicable from the electromagnetic viewpoint and which provides the connection with gravitation. On the basis of further experimental work from 1923 to 1926, Townsend Brown in 1926 described what he called a space car. This was a revolutionary method of terrestrial and extra the flying saucer terrestrial flight presented for experiment while motor-propelled planes were yet in a primitive stage. This engineering feat by Townsend Brown was all the more remarkable when we consider such a machine produces thrust with no moving parts, does not use any aerodynamic principles of flight, and has neither control surfaces or a propeller. Townsend Brown had discovered the secret of how the flying saucers fly years before, and such objects were reported. Now, the basic differences between electromagnetism and electrogravity have been described, and the basic principles of the Biefeld-Brown effect have been outlined. We are finally ready to understand the principles of astronautics or the conquest of space. The Earth creates and is surrounded with a gravitational field which approaches zero as we go far into space. This field presses objects and people to the Earth's surface. Hence, it presses a saucer object to the Earth. However, through the utilization of the Biefeld-Brown effect, the flying saucer can generate an electrogravitational field of its own, which modifies the Earth's field. This field acts like a wave, with the negative pole at the top of the wave and the positive pole at the bottom. The saucer travels like a surfboard on the incline of a wave that is kept continuously moving by the saucer's electrogravitational generator. Since the orientation of the field can be controlled, the saucer can thus travel on its own continuously generated wave in any desired angle or direction of flight. Since the saucer always moves towards its positive pole, the control of the saucer is accomplished by varying the orientation of the positive charge. Control, therefore, is gained by switching charges rather than by the control surfaces. Since the saucer is traveling on the incline of a continually moving wave, which it generates to modify the Earth's gravitational field, no mechanical propulsion is necessary. Figure 4. Saucer movement. Control.
Okay. Real
Well,
quick.
they said it.
Yeah. It's just where you put the charge, right?
Where you put the charge, flip in the field.
Yeah.
Yeah,
everything-
and he also said that the positive is aimed down towards the ground, which is interesting because we know the air is positively charged and the ground is negatively charged. So it's riding it like a wave.
Yep.
That's interesting.
Real quick, I'm going to show this one. Now watch.
Is this is one of the traditional lifters?
This is not ion lift.
No. Oh, he's got a weight on it.
Ion wind does not lift weight.
That's a weight in the center, I take it.
Yep. It's a little disc with a little motor. Let me tell you from experience, any bit of weight on any one of these things is instant failure. I mean, just the CD alone would make it fail.
That's
There's
cool.
nothing out of shot. It's all right there. You could tell when somebody's flipping the field versus somebody with ion wind.
It's really stable too. It's doing like a nice little lock.
Yeah, well, it's got the little string holding it down.
Yeah, well, I'm saying it's staying nice and stable though. Still, nonetheless, even when he was playing with the weight and stuff, it was making a nice recovery.
Yeah. So to show you right here, the little motor.
If
See if
that
I
thing
can
was
do
able
this.
to freely float and fly, how fast do you think it could go?
Oh, I have no idea.
I mean, it would probably accelerate, as it continues upward.
Just keep on going faster.
They're trying to get. So you see the little motor in there. So let's just put it this way: every time you look at it, every bit of weight counts. Every single bit of weight counts. Every time you add more, you have to add more thrust to it if you're doing ion lift. This is different.
You said that's a motor spinning a disc?
No, it's not spinning anything. It's just sitting there. He
Oh,
just
just
drops it
sitting.
on top.
Yeah, it's not hooked up to anything. It's just what he's using as a weight.
Oh, gotcha.
So I'm going to take this one off and go back to the video real quick.
Analysis and empirical testing. Before UFOs were ever seen and validly reported, Townsend Brown developed a captive flying saucer, a scale model saucer with a free bearing going around a stationary pole. Brown did not start with round objects. In fact, the first object that he flew was a triangle, the next a square, then a square with the edges cut off, and finally a round-shaped saucer. Eventually, experiments proved the saucer shape most effective. Changes were made for empirical reasons. Having solved the problem of horizontal thrust, Townsend Brown developed a profile shape which would be most efficient to navigate the electrogravitational field for maximum vertical thrust. The final profile that he developed was the shape illustrated here, Figure 6, saucer profile. The first report of a disc-shaped object in the sky dates back to the 16th century. At long intervals during the centuries since then have come other reports. Most of them are undoubtedly unreliable as observations, distorted by telling and retelling. But in these older reports, as well as in the very numerous series which has accumulated since 1947, there is a teasing common thread concerning appearance and behavior which makes any certainties about the unreality of flying saucers very insecure. One of the great difficulties in substantiation of these reports is that, in both appearances and behavior, these objects seem to be simple scientific impossibilities. Here are some of the reasons advanced by technical men to prove the impossibility of devices such as the reports describe. 1. The reports reveal in most cases no method of propulsion which can be understood. There are no propellers in any of the reports. Some of the reports describe a long flame jet trailing behind a cigar-shaped object, but this flame is orange-red in color, indicating an inefficient combustion which would make it ineffective as a reaction jet, such as propels rockets and jet planes. No other known physical laws seemed capable of explaining the observed motion of the objects. 2. The reports describe a range of speed and acceleration from stationary hovering to speeds greater than present-day rockets can deliver, and the changes of rate of motion, the accelerations, are far beyond the capacities of any known man-made vehicles. Flight experts point out that such accelerations would impose impossible stresses on any human or human-like occupants. Therefore, they say the reports must be false or erroneous. 3. Many of the reports concern night sightings and describe a glow, usually of blue or violet color, around a periphery of the objects. Physicists have noted that such a glow is characteristic of a very high voltage electrical discharge, but add that this suggests no means of explaining the appearance or behavior of the objects described in the reports. 4. The description of shapes and performance seems to indicate a complete or almost complete disregard of aerodynamic principles. The objects seem not to need the support of air, as a plane does, nor to depend on the lift provided by properly designed surfaces moved rapidly through an air medium. These are weighty arguments, provided the assumptions behind them are correct. As I have previously indicated, the observed motion of a condenser has been labeled the Biefeld-Brown effect. Studying this effect, Brown pointed out in 1923 that this tendency of a charged condenser to move might easily grow into a new and basically different method of propulsion.
Okay. So it's kind of interesting the way they start describing this stuff. And everybody puts these things in a vacuum. And traditionally, if you see them, we're not necessarily in the same vacuum. They're putting in a negative vacuum. We're in a positive vacuum in the earth. You know what I mean? So the visual look at it in a vacuum would just simply be what the negative on the outside, the positive goes to it, and then it gets a big glow that comes off of it, like a star device or something like that in a vacuum. That's what they're looking at, right? But you're never going to see that in the Earth's atmosphere. That's not what you're going to see. You're going to see the interaction between the water and the atmosphere and the device itself as it comes into contact with the electrostatic field and the negative radiant energy. That's what you're going to see. So it's going to look semi-blurry, right? Or at some points, little spots shining off it or something. You're never.
I mean, the reason that you would have that type of effect is to do with the gradient of the energy field that's being created as it interacts with the environment. So because it's a gradient type effect, that would cause that type of distortion of the atmospheric waveforms.
Well, yeah, I want to say this because the stuff builds out like a gas. Okay, it's not a gas, so don't try to get me wrong on this. It just builds out that way. It goes through everything. So that outer field, by the way, I do a lot of experiments with it in water because it simply loves water. And I can't explain it to you. It just does. Every time you put it in there, it's energizing the water and pushing light bulbs several feet out, right? It gives you an indication of what's going on in the air around it. Mist, fog, anything like that with some water content to it. It's directly interacting with it, and it loves to interact with it. That kind of gives you a hint of what's going on. If that's your outer shell of your field, then that's the exact thing that you're interacting with in the air. You know what I mean?
I wonder if it has something to do with protium, being abundant in water, and plasmoids using protium as an energy source.
I was going with the hydrogen density of water, and the fact that it kind of bridges the gap between energy and matter, as far as there being a lot of free hydrogen available.
Yeah, like it's just this good medium.
Yeah. Well, right. It's the ideal medium, realistically.
So he said water has more dielectric potential than air. It's interesting when you do the test and you're looking for stuff. So let me just say it this way. When I do test, I'm looking for something specific, and I just tell you what's going on in the test usually, but I don't tell you what I'm looking for. I'm looking for it to interact with the water. I'm looking for this field to build out the exact way that I'm seeing it built out on a UFO. So if we're seeing these things take presence that are going on in there, is your electronics messing with it? What field messes with your electronics? Why is it messing with them? What in history matches that description? So you go back and look, okay, all the car stuff shut off. They went over a nuclear facility and it started to mess with that. They started to trigger the nuclear weapons, right? What can cause that? We know that electrostatics can cause it. I also know that this field too close to it will cause it. Now, could it be neither one? Sure. But when you could sit there and run a machine and then have your computer flip on and off different web pages, you know that you're going to have something there. That's kind of the field you're looking for. The fact that it interacts with the water is also huge. You can't discount that in any way. It's what's needed. So it's building a thicker and thicker field on the outside as it pulls that stuff in, and then it's captivating that static electricity even more. So
yeah. I wanted to pull something out of the comments that was kind of said and just throw out my 2 cents about it anyway. It looks like you all, Adam, said about the dielectric potential of water being greater than air. And then Eighth Center coming in and kind of saying that he disagreed. And I liked how he said this. The air is there. It's just stuck in a self-cycling system, right? That's actually a lot like a good analog to the static in itself and how the static operates. It's together and attracted to itself, but it also spreads and moves. It doesn't have a definite direction or flow unless it's contained, right? And that's the same thing with the air and the atmosphere. There's different properties of different air masses that come in with other air masses. It's where these air masses interact that the effect comes in, right? We always know that it's at the plane of interaction between the two differentials. That's where your storms are coming from. That's where the moisture is being sucked out of the ocean and the lakes from, and the atmosphere by large and whole, right? That's where it all happens, is at these these points of interaction between the two, but they are all free in unto themselves and going with their own flow and in conflict with one another. And this is the same exact thing with static fields as well, and it works almost as an analog to it. So it's just interesting to make that correlation.
Well, think about it. When you talk about a hurricane, you talk about a tornado, right? What is the first thing that happens? Weather conditions. You're messing with the water in the air immediately. As soon as you do it, this thing's building up and it's pulling in the water to it. It tells you everything you need to know about the energy you need to create. We're not trying to create something that's not like the earth. We're trying to create it exactly like the earth. That's the thing. So when you start seeing that kind of storm build up, the water coming around it, things like that, that's trying to tell you something. It's perfect for interacting with the water.
Yeah. And it's at those planes of interaction, like you said, that these things occur: hurricanes, tornadoes, and larger cell storms and things of that nature, right? It's just interesting to realize how these two fields that are basically similar in their composition are interacting with each other in such a way where they have flow of their own, except it's very light. Okay, it's very light. Mm-hmm. When they interact, however, it not only amplifies in severity, but definite movement at that point is introduced, a definite flow. So it's no longer meandering, and kind of going along and riding together, with a little barrier in between. Now, all of a sudden, with that conflict causes the spin of these things, right? And that's what we know. Hurricanes, they spin. Tornadoes, they spin. A good cell, it's got rotation to it. And, that has so many different environmental factors to it that all affects it, right? But at the root, that's sort of what it is. And when you're dealing with these fields, this is sort of what you're looking at as well. When you reach these high densities of the two interacting fields, you're going to get that flow. And that's the same thing as the spark jumping the gap at that point, or turning from one state of electromagnetism to another. It's analogous.
So couple things real quick. Lightning presents as static electricity in the beginning until it builds up high enough in order to shoot the lightning, right? So that's present. What do we normally put with these? But the magnet. The magnets create the swirling. If you ever looked on, say, the Weather Channel or something, they'll tell you that there's swirls in the earth, okay? And it's by some land masses, sometimes it's over the ocean. And you'll see the water swirling in there, and they always show it. What's going on there? You have a thinner crust in that area where that water is swirling, because underneath your feet, we have light magnetism. Well, light where we're not feeling the magnetic effect right away, but it's definitely there to swirl the water and stuff. Anybody who's done any experiments with that, put the magnet in the water, put the other magnet under it, what happens? It starts swirling. It's the same thing. All three things are always present when you start to get these fields that are going on in the earth. That's why they're always present in the UFO experiments.
Yeah. Bouncing back into the comments again, talking about water as a liquid crystal. I mean, that's something we well established. And I know that we're in full agreement on. I think it's important, in differentiating the difference between water and then air, atmosphere, right? Is that the air in the atmosphere is not void of moisture and water, right? It's significantly, water,
right,
in nature in itself, right? So it's just a lower density version of, water as it is condensed and so on, like on the surface of the planet. It's just a lighter density of it, and shares a lot of the same attributes too. So, I mean, that's present as well. And I think that, as obvious as that is, it goes without saying, because if you're looking at an atmosphere that's void of moisture, then it's a totally different circumstance. That's not where we're at, though, right? So, yeah, I'm just throwing that in there.
Also, somebody asked about the vacuum chamber right here, the Faraday cage. This energy blows right through a Faraday cage. The negative radiant, it goes right through it. It goes through everything.
Yeah.
It
there's
literally,
nothing-
unless you got some, dinosaur goop in there or some tar. You know what I mean? It's going right through it, buddy. There's no Faraday cage that can hold this in. I mean,
Yeah, I mean, there could be like, the most depleted states of matter that exist, potentially could, like lead and so on. We know that could potentially block some stuff. But when you're talking about extra low frequency type stuff, you're not stopping it anyway. Most of the time.
Yeah,
Yeah,
nothing that easily at hand, anyways. you
Yeah.
know?
oh, trust me, man. I put foil all around this, being foil balls, everything. It went right through it.
Yeah.
Just
You're not going to
blasted.
put a metal garbage can over your head and be protected. It's just not
No.
gonna happen.
Dude, it seriously blasted right through a bunch of stuff. It was crazy. Every time I mess with it.
I'm still impressed with the burrito, to be honest.
So think about it though. You're exciting water inside of a structure, right? So it has a skin effect because it has a tortilla around it, right? So what are you doing? You're cavitating the energy inside of that as much as you possibly can. So what happens to the energy is the energy actually increases the amount because it's not automatically flowing out right away. It's holding in like a capacitor and then leaching out. So your amount of energy gets higher. When you connect it to more and more burritos, the reason it turned on that other Tesla coil is because it had like 3 to 4 times more energy by the time it got to it than when it started. That's why it just went to the number one coil and turned it on like it was a regular Tesla coil. So you can sit there and play with it and get plasma out of that second Tesla coil just going through 4 burritos.
So, I mean, what's interesting about that is if you think about a microwave oven and how it works, I mean, we think about it as like exciting the water molecules, causing the heat and the friction. But at the end of the day, like that's ignoring the fact that, water is self-organizing and likes to connect with itself, right? We've all seen 2 drops of water, and what happens the moment they touch, they bang right into one, right? They have that property about it. So anytime you're introducing a waveform into that water that's riding in between them and separating and pulling those things apart, that's the excitement. Okay, it's actually pulling apart that inherent natural bond that they have with each other that's creating that movement, that's creating that heat in that context. Now, when you use the flip side of the coin, what does that mean you're doing? It means you're pulling the energy, you're pulling the water together. You're creating a higher density water state, and greater organization of the water molecules, better than they could naturally achieve, right? And that in itself, that's fusion. Well, not exactly, but that's a fusing effect. It's an attractive effect, and just like when you stretch a rubber band and it gets warm, when you let it go, it gets cold, right? We know that. You stretch the rubber band apart, it gets warm. You just put it back, it's cold. Same. It's the flip side of the coin.
Yeah. By the way, I did it with grapes too. Just
You have anti-plasma.
well, yeah, but then I put the 2 grapes together and it created plasma between them. It was pretty interesting.
Yeah,
So,
Nathan creating dark plasma.
kind of interesting stuff there. I guess you just got to look at why it's doing it, not just what it's doing.
Yeah.
I mean,
The why is more important, in my opinion. I know that's silly, but understanding the why allows you to solve a lot of problems.
oh yeah, because it directly relates to the next project you're doing. If you can create cavitation in this thing, you already know you have more energy. You know you're creating a capacitor right there. That's why that device I'm working on is so important, because it's cavitation everywhere. It's holding energy fields in. You know what I mean? It's creating a structure where it just pulls everything to the center. You know what I mean? That's
the
what it
giant sphere
is.
you're working on.
Yeah, because there's a big thing in there. People ask, is it mass or is it energy that creates gravity? Some people think just spinning a giant object is going to create gravity. And that's the way they think about it. And I disagree. I think it's the energy field you create inside that spinning object that's going to create your gravity.
No, well, I mean, there would be centrifugal forces involved in.
Well, yeah, but
in that. But I mean, that only has to really do with the matter that's in that direct relationship. Once you get the charge separations out of it, like those effects should be countered, and especially if they're counter rotational and opposite. Isn't that sort of the idea?
Yeah. Well, yeah.
Right.
The friction.
I can't even begin to tell you what this thing's going to do, but I'm eager to find out. That's for sure.
So somebody asked me for an update on it. I printed a couple things out, wasn't happy with it, and going back to reprint them again. So it's basically all there. It's just going to take a couple days to pull it out. I had some insets that I wanted to add in there, and I didn't like the depth of everything once they were put in there with my soldering iron. So I'm changing that. I didn't like the bumps on the magnets because we want to go electrics in there. Or even if we can get some of that bismuth and nail it out, I only want to drill holes for the actual studs that go in there. So I flattened a lot of that out and smoothed it out so that we can put stuff in there. And if there's any way I can pour and cure it quickly by taking the ball on the inside and putting ice in it, and then putting the outside coupling on the outside and pouring it and letting it just cure quickly by putting another one on the outside and ice in it. You know what I mean? By creating ice on both sides, I can cure it quick without melting everything right away. Then that's what I want to do. So
I think it's worth throwing out there, Nathan. You know, like I'm reading the comments, and Yuel Adamus, I don't think I've seen him really on the chat all too much, and pardon me if I'd missed him previously, but like, you know, he's been paying attention. Like most of what he's saying is exactly what we talk about all the time, and I think that that's important to point out because, you know, it feels like we do get the same sort of questions about this stuff all the time. So, you know, props to you, man.
Yeah, who was that again, Joe? I want to put up their comment if I can find it.
Yeah, no, he's got a bunch of comments on there. Yuel Adamus.
Okay.
If I had to guess, he watches a lot of Ken Wheeler.
Yes. Well, he's a smart guy.
Well, listen.
Ken Wheeler.
Ken is a smart guy.
Yeah. Yeah. Right there. Okay, now I found it. Right. That's the one, right?
Yeah, he made a bunch of comments. Most of the stuff he's saying is straight on point. So I felt, you know, I hadn't seen him in there before. That's a little shout out.
I've seen him like a week ago, I think it was, or maybe like one or two of the lives ago. Yeah. Yeah, everybody comes in here, man. He's got really smart, seen a lot of this stuff. I'll be honest with you, man. After running thousands and thousands of tests, some of this stuff kind of falls in line in every single thing that they talk about.
Mm-hmm.
And, you know, if you only got magnetism, you know you're missing a part of it. You have to know it, or else you haven't done enough testing, because you don't have a field that holds in a field. You're not going to take your magnetic field and hold in a static field. It's just not going to happen.
No,
you know what I mean?
You got to have a gradient, and that gradient, you know, exists. You know, like you said, it's the reverse end of it, but it's also like, you know, what the observable effect of that is, aside from what's inside, is a plasmatic gradient that has to occur because of the interaction between the field differentials.
Yeah, that's kind of, you know, one of the questions that comes up a lot of this is, do you need to create the static if these things are in constant motion and counter rotation, or will it naturally create the static if you give it the right environment? It's always interesting to look at it that way. And then, you know, at some point we build crystals and frequency and stuff. That's going to have to come into this experiment at some point, because we know the Earth is chock full of it. Now, we get the frequency from, you know, the devices we put into it, but it's always interesting to know that if you put, you know, crystal in water, you're going to get a frequency out of it, because it's creating energy. Yeah, well,
That makes sense, though. Yeah.
if it creates 0.765, say millivolts,
Mhm.
in order to create that, you must have frequency. So why it's creating the frequency, this is the interesting part. The frequency is the shape. That's the important part of it. When you look at crystals and how they're formed and why they're different ones, because they have different frequencies.
That
That's
makes sense.
it. The water molecules are designed, excuse me, the air in there is designed so that it goes in that pattern every time. And it creates that formation.
Yeah,
That's why
frequency is geometry. That's, that makes
That's
sense.
right.
So it all goes back to the basics.
That's why when you put one in there, it does a certain frequency and it'll grow the same crystal over and over again, right?
Mm.
So what happens now when you start putting two different type of crystals in there, two different type of salts? Do you get something that's totally different? Well, Joe and I looked at this, right? What was the
You do.
experiment, Joe? It was salt, regular table salt, and was it what was the other one? They made the pyramids instead of squares. They took, I think, Rochelle salt, and they also took regular
I
table
don't
salt.
know. You didn't use Rochelle. It wasn't Rochelle salt though.
Which one was it?
I don't know. I think the last time we talked about this, it was salt and granite, man. I think that's what we were talking about.
No. You showed me a video a while back where they went from a cube shape when they put in regular salt, but then it started creating pyramid shapes.
Oh, right. No, that was just regular table salt. Yeah. And all they did was add alum into it.
There you go.
Like a very small amount of alum into it. And then it changed the entire crystal structure. And the alum doesn't even accumulate in the salt crystal. So what you're getting in the salt crystal is just the pure table salt or kosher salt, whatever, and the alum's left, but it changes the resonance of the water at that point, and that creates a different, entirely different crystal structure.
This is
That's
inspiring me to want to do more cymatics tests. I don't know. What do you think? That sounds fun.
I mean, we've talked about cymatics tests and stuff like that, and just generally letting things that cure and solidify do so in an environment, in certain resonances, and see if there's material effect to it. And I think that there would be. Might be at the molecular level, so
Right.
it would be hard to see or tell necessarily without having proper equipment.
That's an important thing to consider. Yeah.
But then again, the ideas like that also make previously impossible types of metamaterials and compounds and stuff, that wouldn't have been possible. If you get the certain frequency into a medium like resin, for instance, who's to say that you can't add, some type of ionic charge into the resin and change the entire crystal structure and material, therefore, of the resin as it cures, just through ionization of another material. That happens with quartz all the time. It's hard to say why that wouldn't occur with the resin. Maybe it would be more difficult because resin's organic, and a lot of these other crystal compounds are not. But it's still something worth exploring.
Sure.
I had a question for you. It sounds crazy, but I was looking at roofing tar. Now, I know they're making dielectrics, but I was looking at it in the context of if the tar pits can hold back this type of energy, would this substance also hold it back? It's pretty thick. It's nasty. It slows things down. Like mineral oil slows things down because of the viscosity of it. So
I'm just warning, if you're thinking about working with it, it gets on everything.
yeah, I know.
It definitely does.
But yeah, I'm sorry, I didn't mean it. But yeah, it's nasty to work with.
It
Sometimes.
also never fully solidifies, even when it's solid. It's always in that pseudo liquid state.
Nasty goop.
Yeah. Yeah, it's really hard to work with sometimes, but I mean, I'm interested in to seeing what your test would be with the substance, with that kind of
That
substance.
goes right back to what I was saying about the oxides. It's a depleted material. That's the whole point. Is
Yeah,
that the
sure. Yeah.
whole nature of that tar's existence is that it's been at almost full form of depletion and is in constant and is in full concentration at that point of
Mm.
environmental depletion. So it of course it would be a great dielectric. You
Yeah,
know, it
that makes sense when you put it like that. Yeah.
Yeah.
it'd be curious to see if it, held it in. I'm thinking about the experiment I'm doing, and also just taking a very simple pipe and, putting it around the entire thing, and then putting another pipe over it, and then filling it in with a frosting bag, and try to, get it as tight as I can. If I set off that energy inside of that, would it hold it in? That's, kind of the precursor to putting it in the big device. But
I
that
think you
would
guys
be
have a good
interesting.
hypothesis that's definitely testable, so.
Well, it's only until they get that electric, perfect, where I could just peel off sheets of it, cut it and slap it in. That's what I want to do. So, but there's about this much space in there now. I went through and reworked it. I got about that much, which is, like I said, a 1/4 inch or so of space. It was an 1/8, and now I got to a 1/4. And we should be able to do some real cool things with that.
Nice.
You're real fast at building that stuff too, I have to say. Like you got that stuff on Fusion 3D real fast, and you showed us like in almost a couple of days. It seemed like you put it together real quick. So I just want to give you applause for that.
Oh,
some really nice work, and it's very fast for how precise it is. So impressive.
Well, I've been spending some nights in there, man, working with this thing and reshaping it. So it's I don't know.
You've been spending some time in the shop. Yeah.
Are you in production with it yet, or are you still playing with all the proportions?
I printed out like 5 parts, and I wasn't happy with some of them, and had print shifted, things like that, because I'm trying to run them fast to see, did I get all the bolt holes? Did I get everything in there? Did they line up on, all the bearings, the pipes, everything? So, and then did I build them too small? Is it going to work fine? Is it a good test? And you know what I ultimately came to? F it. I'm just going to put it together so I can have the device ready and I can just change parts out.
Yeah, send it. Get one together just to see what's what. Because if you kill yourself in these small stages, all you're going to find is that once you get one that seems perfectly right, you're going to run the thing, and then you're going to have to make some other kinds of changes anyway. So you might as well just save yourself that work. Get it together and just see where it's at.
I think he'll be fine as long as he wears a hard hat.
I think he should be wearing a lab coat, but that's just me.
Yeah, that too. we all need lab coats.
Just so you guys understand, I wanted to put out the STL so other people can manipulate them and put in their ideas and run it their way. But I wanted to make sure everything worked and I could show them how it goes together. That way, they can go, oh, okay, well, this is a simple part. Once I printed it out, I can go ahead and build my own, right? Or change it however I want. Bigger magnets, whatever your mind thinks of. That's why I wanted to do it. So,
I've seen similar things where it's like there's magnets around it, and then if you spin it once, like counter rotationally, and you pull shift it from the internal magnets, and then there's a sphere inside of it, the sphere inside, spins more than what you input. So it's actually right then and there, it's a positive gain. But they're just really using and manipulating the fields and the proportions, of the inner and outer sphere in that case to get the additional rotation out of the center. But it was a long time ago. I want to say it was like 3-4 years ago. I saw a video like that, and I'd love to hunt it down because it was actually interesting. If nothing else, it just shows like that the transfer of energy, could potentially be greater. Because realistically, it would take the same amount of force to stop what was on the inside as it did to what turns on the outside. So getting that gain in rotation wasn't at a loss, right? I think that's where the point is.
That makes sense, because you see the same thing happen when I'm spinning the neodymium sphere inside the Rodin coil. You know, you have the electromagnetic field that's spinning, and then you also have the sphere that's spinning. You know, it's reducing the input power, so it's actually, you know, generating a lot and adding to the system in the same way.
Right, and they do have magnetic like transmissions, like multi-gear transmissions and things like that.
That's right. Yeah.
Also, that have 1-to-1, but they're still relying on gearing at that point to get the greater energy out at the rear end. But the whole point is that there isn't a loss in the shift, right? So it's an effortless and delayless shift between one gear and the next.
Well, it's going to have to get back to the motor to add the energy, isn't it? Because you have multi-spheres rotating on the same motor. It's not just one by itself.
Right. Well, I mean, in your case, and I've already considered that too. And that's why I actually said, when you're powering these things, if you get one of those higher end Dremels, they have a computer chip in it that has like a load adjustment. So when you lean in on the thing, it knows the extra load is on there, and it actually will increase the RPMs to keep it consistent based on the load that's on it, right? So not only are they super high RPM, but they're also, actively adaptive. So, whenever you're dealing with these internal potential like torsion fields and stuff, they could get really, I think it could get pretty rocky, man. Like, there's going to be a sweet spot of the rotation though, that I think that would probably be overcome. I just don't know what that figure would be.
So check this out. Improving the gravity. It's so funny. We're going to prove the anti-gravity at the same time. If we can show how gravity is made, we can show how anti-gravity is made. It'll be that easy. They've already told us how they say it, through the Biefeld-Brown effect. I'm just going to show it in the reverse way.
You beat me to it. I was like, hey, for anybody that watches all the time, you've heard this before. They didn't run it in reverse.
That's right. That's what Gerald tells you. That's right. Watch great.
Right.
We'll definitely have Gerald draw out the circuits. Oh, man.
Yeah. Imagine trying to get out of a parking space, if you couldn't back up.
Yeah.
You know what I mean? Like you'd say, I could never get out of here, right? And so there's a curb in front of me. There's a car in front of that. There's two cars next to me. How the hell am I going to get out of this parking space only going forward? Back it up.
Yeah. I just find it interesting. We're going to use the same fields and just going to do it in reverse. That's it. And they always say with gravitation, you're going to get time dilation. So I'm interested to find that. And I'm going to tell you right now that little gravity fire, everybody makes fun of it a little bit, but man, does it teach you something about every single field you need to know if you just know how to do it? Like somebody told me, he goes, well, you're not really putting a whole lot of static electricity in there. I go, well, you don't know who I am, do you? I'm going to force everything to the limit. That's what I do. You know what I mean? I poured so much static voltage in this thing. Like it was literally spraying it. Like you would take a dryer sheet and hang it, about a foot away and it boom, right to it, man.
Dryer sheet.
Yeah.
Right. The thing meant to defeat static.
He walks by it and his whole jacket's just sticking to it.
Oh. That stuff, man, it literally makes the best thing. If you want to increase the static voltage between two plates, run it in there, man, with a really low amount of amperage, really high volts, and put it right in the middle. And then everything in your garage will start going off. You know what I mean? You'll have computers over here turn it on. You'll have all kinds of cool stuff. It's just like all over the place, man. Yeah, it was a pretty gnarly ride. That and paper sticks real well. It makes a massive force against it based on the structure of the interlocking of it. It pulls against things real hard. So if you create air in that field right there on that piece of paper, it'll create a bigger force against something. So I don't think a lot of people understand that about static electricity either. You don't need a Van de Graaff. You just need the right amount. You know what I mean? And
Mhm.
boom.
You know, for in the aerospace industry for a long time, they used the conductive carbon fiber weave that has copper strands literally interwoven in with the carbon fiber mesh. Here's what they don't tell you is that when they build the components, okay, out of the natural resin that they use,
Mm-hmm.
it has all aluminum oxide in the frigging impregnated into the resin. and then they're running a semiconductor conductor and a dielectric all like in one uniform piece of interwoven glory. And this is in the aerospace industry. So, they don't tell you what it does and they don't tell you what they use it for. But ironically, it's not like the material itself is classified. You could actually go buy the material, and people use it for like knife handles and stuff because, it looks great. It looks great because it's black carbon fiber with bits of copper running through it. It looks fantastic.
Yeah, that sounds
Nobody's
neat.
thinking like, oh, well, what's the actual use of this?
Yeah.
Yeah. They call it all sorts of weird gimmicky things. They'll call it like like lightning carbon fiber and stuff like that. Like they're trying to sell it off like because it's got the conductor in it that it's able to like take on electricity. They don't explain it, like in any sort of way. It's just all just super surface level thinking stuff that they use to market it to the general population, but that's not exactly what it is.
Yeah. So funny, man. But yeah, a lot of the stuff with copper, though, man, copper sucks things in. It causes problems when you're starting to work on some of this stuff. So one of the things that people should know is in order to create the anti-gravity, you got to beat Lenz's law. So I know a lot of people out there don't think it's possible, but when you create the negative radiant energy, it absolutely does not interact with your magnetic field in that way. You can literally just take it and put it over top of this thing, and it's not going to pull it towards it at all. And
Yeah, there's multiple ways to bypass Lenz's law, theoretically at least.
Well, it's not theoretical. I've done it. It flat out will accept the energy. It will not interact in the same way. It just doesn't have that part to it. That's why it couldn't be static electricity that you're creating. You would still get a magnetic component and it would still interact in some way. So in this stuff here, it doesn't interact in that way at all. You're forcing the field, the magnetic field inside the device and then the outside, and it changes it completely when you flip it inside out. That's why it doesn't interact. It interacts with water differently than, anything else.
Now, I'm not a proponent of talking all too much out of line, but it's all right on subject. And
Go ahead.
Like what is going into the center of the Tesla coil and what we're kind of talking about now, okay, and then what's being discussed in the chat and what I said earlier, you need to start putting pieces together as to the extraction of some of the cold energy sources and how that actually is accomplished at a high rate of efficiency, and it all has to do with differentials. Now, that's all I'm going to say. Like, you could either figure that out or you can't, because I'm not your mom and I'm not here to explain everything to you. Like, you got to be able to understand the concepts of these field compressions and then how to maximize that field compression, what affects it, what doesn't, in order for you to fully get it. I'm not trying to throw a riddle out there. It's just take a look at the videos and notice a consistency, and then say to yourself, why is it always this wire down the center that's doing it? It's not a magic wire, it's just a regular wire, right? But it's always the same wire, same type of wire.
Yep.
Why, people? Well, why? Like, this is for you to figure out. Like, there's only so much we can really tell you.
Well, that's why you always got to do the experiment the same way the inventor did it.
That's it.
You got to find out why he did it that way and why it was working that way, because in other ways it won't work at all. And you don't think that you changed anything, but you did.
Mm-hmm. Right, because you take a raw piece of copper wire and you shove it down the middle, and you're like, "How come this doesn't work?" I don't know.
Why doesn't it have the same
I don't even
effect?
run experiments, and I know why it works. And it's not something we talk about.
No.
But I'm also not saying the quiet part out loud. You either get it or you don't. Like, I don't know what to say.
So what is everybody looking for? Longitudinal waves? Is that what they're looking for? They have transverse and they're looking for longitudinal in order to get anti-gravity. Have you ever seen one?
A longitudinal wave? Well, I mean, I have good eyesight, but at the end of the day, like, I can't see shit that is invisible.
No, I mean, fair
I've
enough.
seen somebody demonstrate it with the spring.
Have I ever seen it? No, not with my own two eyes. Like, I can imagine it. It goes this way instead of both these ways.
A spring. Oh, I'm just asking a simple question because a lot of people say out the same buzzwords all the time, but they've never seen the field. You know what I mean? That's what's so interesting.
Well,
how do you identify what it is when you've never seen it? And why is it so different from the other fields? You see, when you start saying static electricity or magnetism, why is that so different than what we're working with? Do you know what I mean?
think this is how theory gets separate from experimentation. People who just theorize versus people who, actually experiment. Sometimes things are different when you actually experiment, and they can't be fully explained just by theorizing,
Well, they could be fully explained by theorizing, but theorizing can't take into account all the environmental
right
intricacies of any given system at any one place at any one time. I mean, listen, Ian trumped me on that. Yeah, you're right. I've never seen a longitudinal wave because we only hear them every month.
I
love
can't
you,
hear.
man. Wise as I love you, bro.
No, he's right. Yeah.
He's dead on. That's fair.
I want to throw things out there for people like that because they always get the same buzzwords in the comments when they like reply to my videos. They always say the same things, and I don't think they've even like dealt with the field that they're talking about, because the next very thing is going to be, oh, it's a static volt, it's a magnetic field. Well, no, you didn't listen. Number one, to what I said. Number two, you have no idea how it builds out. You don't know why it's important. You see, I had a lot of people ask me a simple question: what's this good for? Can you start a motor with it? Can you run a motor with it? Can you create over unity with it? I don't give a flying fuck, to be honest with you. That's not what it's for. It is literally an anti-gravity wave that I'm working with that I want to propagate. And that's what I'm using it for. Do I care about those other things? Hell no. I don't care. Look, it's fun to try. It's fun to play with. Do I care? No, not one bit.
You did it the smart way, though, man, in my opinion, because you knew at a certain point of playing with the gravity flyer that you'd seen things that you never expected to see, but you also didn't fully understand at those points. So what'd you do? You did the smart thing, and you went back to the book, and you knew who knew all this stuff all along. So what'd you do? You went through the same exact motions that he went through, right? Saw the observations and then scaled it in a way that made sense for you to then take what you've learned and try and, bring it back to square one again, but knowing a lot better off this time what types of energies are involved. Because, I mean, I can't speak for what you knew or didn't know, going into your Graviflyer experiment, but I'm going to go out on a limb and say that it was a learning experience for sure. And on top of that, it's also a lot of following just what little instructions were out there to have the same result and achieve the same result. Had you just did it and got the same result, chances of you knowing what you know now about all of this is probably slim to none, because you would have gotten the result and it would have ended right there. Kind of like an instant gratification thing. But
Yeah.
you had to go through the learning curve and the growing pains of understanding all these systems and processes, fields, and how they interact with each other in order to get to the point now where we could even have this type of discussion at this level, where it's just pretty free flowing. And it's like, hey, and we have points of reference to reference back to as far as what your experimentation has shown, the theories we've discussed, and how that's manifested in your work over time. I think that that's the best way possible, gives a deeper understanding to the subject and exposes more people to it along the way.
I 100% agree. Well, you seen that when I transferred over from working just on the gravity flyer to the Tesla coil, because there was something wrong. There was something that didn't add up. And you go back to Tesla, you go to Dollard, you go to Linderman, you know what I mean? You start to really look at what they're trying to tell you and see why things are working the way they are. And what are they seeing that you didn't see? When Tesla said it came out like a gas, it was like, well, hold on. How does he know? You know what I mean? How did he know that? What did he see that we didn't see? Because everybody describes the same thing over and over again, right? And look, I'm as guilty as the next guy. I went out and used all the buzzwords, right? But I didn't really understand what Tesla was trying to tell me. And now that I see the field, I can see it very clearly what he was trying to say. It was something completely different. And he knew there was two sides of it, just like there's static folds and a very high magnetic field.
Yeah.
There's always two sides to it. You have to figure it out. So, yeah,
something to bear in mind about Earth energy, and just like proof of concept, so to speak, is you ever notice like how there's natural separation of organic and inorganic matter?
Mm-hmm.
Like you might have rocks in Earth, but whenever you come to the mountains, the dirt is just simply on top of it. You could sit there and say, well, I mean, that's plate tectonics, that's all this different stuff. But you got to realize that the surface of the planet is in a constant state of cycling, and things that are organic one day can ultimately be broken down into inorganics molecularly at another point in time. That's how these inorganics came to be in the first place, right? So when you have the separation of things, and then within it, separation of also elemental materials. This is why you end up having prerequisite type minerals surrounding other types of ores and precious, metals. A lot of times, when you go into mining and stuff like that, you're looking not necessarily for what you're out there looking for as much as you are the associated more common minerals, right? Because if you find this and that in a certain location, that means that you're onto the ore that you're looking for, right? It's going to be there. And it all has to do with how different elemental materials precipitate out in resonance with these other earth functions, and they're all working in conjunction with one another at a macro level. And it's not all that much different than how an organic body, right? And I'll dance around it since that's what we're talking about, right? An organic body differentiates different cell types throughout your body, and they're present here but not there, and so on and so forth. It's because that's how you're programmed to be in your own development. But it all has to do with these resonances during your initial development as to why these certain types of cells accumulate here but not there. And it adds order to the construction of organics and inorganics. So you can either see that correlation or you can't. Like but it's there.
Oh yeah. It's like when you first put this energy into water and then you put it with sand or glass and you start to see the reaction to it, or you put it with quartz and you're starting to see, hey, this stuff is interacting together. Now, what kind of moment is that when you know the earth is made of all of this stuff and it's everywhere? If you could pull a big enough field of this off, what are you going to go through? What is it going to interact with? What is it going to do to the earth? That's the whole reason you do this kind of experimentation. When you find that aha moment and you realize what it's really working with, and the other side we can't talk about on YouTube, you know you have it. They always describe it in every one of these things when Tesla talks about it. It is directly drawn on the hairpin circuit itself, why he used it. And if you ever read one of his lectures and he talks about that circuit, you'll know exactly what I'm trying to tell you. It directly interacts with that. And if you could figure that part out, you have it. You know that you have exactly what he's working with.
And our audience is on to reading between the lines on it tonight. They're picking that out of what we're saying, and we're not saying it, and we're not even really going there. So kudos to you. you've put in your homework before the episode. Good deal. It's really, really incredible stuff. I don't know. One thing that always water's so interesting, right? And this is a little off, I think, but it comes to mind. But surface tension of water, that's got to be like one of the most interesting things that's out there, is just the surface tension of water, both because it's present right here on Earth atmospherically under these conditions, but it's also present in space. Where you're not dealing with gravity. Water still has an inherent surface tension. And that to me is kind of crazy.
Yeah, well, somebody mentioned it earlier. I can't remember the name. Structured water.
Structured water, yeah.
Yeah, the fourth state, I think is what they call it. That happens when you put in like a positive and negative in there. So basically, if you ran 5 volts in there, it would structure the water in certain ways. But then when you put the energy I'm working with in it, it completely deconstructs that whole thing it just created.
So let's talk about that structured water and something real quick. We talked about storms at 2 pressure intersections, right? What happens when it's frozen and it's a snowstorm and you have the high and the low pressure system interacting in, at that point, and it creates snow? When it crystallizes, what does it look like? It's structured water. Your snow is structured water. Ironically, if you were to go take a scoop of beautifully formed snow and let it melt, it would be structured.
Yes.
And it's already got those resonant frequencies in it from that crystallization formerly, even after it melts.
So when it comes in as snow and it goes down, you structured it in the clouds with the electricity that's in there.
Yeah, it's frozen structured water, naturally frozen structured water.
By the way, he says the mirror. Okay. Mirror potential on the surface becoming a mirror, not only protons, but electrons. So here's an interesting fact for you. Go over to Egypt and look at all their hieroglyphs. On the really important ones you see everywhere, put a mirror to it and see what it looks like on the other side of it. Always 180 degrees out of phase, and it's always the opposite side. So start looking at things. When you start looking at those things, just take the Aken, the Egyptian cross, right there on the part that goes in the center, and put a mirror right there. Tell me what you see. Infinity symbol all day long. You're going to see tubes coming out, like 2 vortexes coming right out of it. I mean, it's fairly simple when you look at it and you understand why they're saying it. I do agree with you, Joe.
But they talk it up at such a basic level, that phenomena, that like it would go right over your head without even thinking about it, because they'll just say refraction.
Yeah, but they don't teach this when they teach you the hieroglyphs. They just tell you it means a word.
Right.
They don't know that it means a science formula.
All right. Well, esoterically speaking, all communication is symbolic and nonverbal. Like at the root core of it all. Like whenever you're into high degrees of meditation and things of that nature, like you'll notice that it's not it's never words. it may translate in your head as words, but that's not how it comes to you. And it always comes to you in some sort of symbolic form, period. And when you're communicating outwardly too, that's why imagination is so strong. If you have a clear and concise vision of something that's so real you can almost feel it, it's because it's more real than you really think. It's your way of communicating with the universe. When you have these vivid thoughts into imagination, it's all symbols and some, if you're praying and you're praying in words, not thought, through imagination, it's less effective. And again, it's all esoteric stuff.
Yeah, it's pretty interesting. I think that it's more interesting to look at that stuff if you understand the science behind each part of it. Then the whole thing starts to make sense. When they say, we put a crystal in to change the energy of the room, right? Say, okay, so what'd you do? Most important part, you placed the crystal in water. You didn't just place it in the room, you placed it in water. Why? Because the water amplifies the resonance that's going on in the crystal already. So what'd you do? You put a frequency in there. When you put frequency in there, it's like putting on your stereo headset and listening. You're changing the mood in your head based on the frequencies that are coming into your ears. I always found that fascinating. So when you look at certain shapes and stuff and you look at different coils, it's pretty interesting why they're building the certain shapes in every single one of them. It's telling you a story. It also tells you how to build it if you pick up on everything we're talking about. So.
Yep. Pretty much.
Yeah. There's a big difference, by the way, between running things in your head and figuring things out based on the writings and when you build it. When you build it, you're going to get the answer. There's no getting around that. You cannot push yourself through it through your mind because you don't know what you're looking for. You haven't found it yet. And that's the hardest thing about all of it is you have not seen it yet. So how do you know to look for it? How do you know how it interacts? How do you know that what they're telling you is correct? How do you know? Like, for instance, if I said I took a DC flyback and I ran it as static electricity, you'd all tell me I'm full of it. But if I told you I ran two of them and I told you exactly why, that I actually reduced the amps in it and brought the volts to the ceiling, then you go, well, that makes a lot more sense for static, right? Well, that's the difference between me knowing it right off a hand by building it and you trying to, figure it out in your head. There's a big difference. You have to build this stuff. You have to see what the fields are. You can't just say, hey, they'll interact right together because some of them won't at all. I put a taser voltage, right, in these things and blasted them. And then I shot the DC high voltage right through it, man. And that sucker was the most violent reaction you'll ever see. They did not like each other at all. It wasn't pushing away from each other. They absolutely hate each other. But then when Sean goes with his Tesla coil and he makes this round ball, right, with the Tesla coil, then the ground wire is shooting electricity into it. It tells you a whole different story that no one's seen. I don't think anybody's seen that except for him until he did that. And then the tendrils that come off of this thing, instead of big high sparks and stuff like that and the color of them, he's working with a different energy. I told him,
that's insane.
I told him, hey, put a capacitor between the ground and the wire that goes to the Tesla coil and trap that energy in there. You may be pulling all kinds of energy, you know what I mean, with how many grounds that you put in the ground.
Oh,
you
yeah.
may be pulling a ton of energy into those caps. You know what I mean? And all it is the Tesla coil was the draw in order to pull the cold energy in because he had created the right environment for it to do it.
It could well be, and a lot of times, as often funny as it sounds, is when you're doing your experimentation and you see these certain observations, sometimes we're so focused on what's going on at hand that you never look outside of that. But it oftentimes the answers that you're looking for lie right around you and just things that you know and how they work, just on such a fundamental basic level because you just look at them every day. And I think that that's probably the critical missing part of any, like, a lot of people's thought processes, is just getting so fixated on, like, this is what's going on with this, that you fail to look around you and see the greater picture of what it is that can help you understand it better. But Sean's stuff is absolutely incredible, and I've said that to him time and time again. The way he runs them are so visually impressive. And just what they do at the same exact time. I know that by just making a couple of tweaks, and I've said this to him before, too, on the side, make a couple of tweaks to it, and all of a sudden you're going to get the full realization of what it's actually doing. And it's exactly what you just said. You might be pulling in super amounts of energy on this, when you run it that certain way, and you put some caps in to capture it. The field compression in some of his geometries have got to be really, really insane.
Well, to the roof.
Because really, really insane, especially in those cone shapes that he was doing. When he, like, I just feel that particular geometry, especially when he was doing it opposite and inverse, with an hourglass, that's the inside of a torus at that point. You're just duplicating the geometry at a higher, higher dimensionality. I think it's gonna exploit it beyond all belief, to be real. And if he could just set it up like you're saying, it would be wild to know what dual field compression like that in that geometry is going to look like. I think it's going to be extreme.
For those of you who don't know, and I'm sure most of you all know, Sean winds his coils in a AC flyback format. So bunch of different dividers, and he wraps it around there like 4 or 5 times, and then he hits the next level, and then the next level, and the next level, and then he puts it in epoxy. So when he does that, it's changing the fields and how they come out. Interesting thing, Tesla once described how the fields of the Earth works, and it mapped out exactly like Sean's coil, his Death Star coil, that round one. It was the same exact mapping. It was ironic. So I sent that to him. It was pretty interesting. Also,
you all's hitting it on the head again, man. This dude's coming up with the stuff today, and it's all stuff that we've always talked about. That the potential is coming out of the fields that are already in the environment, and the whole nature of the tendrils and the reach of it it's totally analogous to a lightning bolt at that point. And we know how the lightning bolts hit. They have to send a feeler out of an opposite charge to make the connection, right? So when you're pulling those, like, it's got to be pulling that from the environment to make that hit. So when it's like, doing it over and over and over again, that's it pulling all the energy in toward it. That's proof of the pudding right there.
Well, think about how a Tesla coil works. The number 2 winding of the Tesla coil is connected to the ground only. Just think about that for a minute. The only connection it has is to the ground itself. Then it goes to the number 2 coil and it goes out, right? Mm-hmm. The number 1 coil is just simply putting a pulse on it. You know what I mean? Putting a frequency and a pulse. That's it. Just like this. That's all it's doing. Pushing it and getting it to shoot up. Getting it to push shoot up, right? So what is it doing? It's like a pump. It's sucking the energy out of the ground and firing it off, right? It's not so much as a transfer as what it's pulling to the ground. If you can look at it that way, then his experiments make a lot of sense. Because now, not only is he pulling it through this energy, he's pulling it in from a secondary ground, and it's going into it. Normal
right, but it's also got to be pulling like where it's arcing out. It's also got to be making that connection outwardly too, meaning that it's got to have some kind of pull in on that too, atmospherically. So yeah, you're getting the pump from the primary, like you're saying, from ground earth, but every time it hits out, it's got to be pulsing inward at the top too, which is interesting because you kind of don't think about it that way. You think about it as a discharge, but what is it discharging to? It's just not saying, okay, I'm everywhere, and where's it going to be? Where it hits is for a reason.
But that's the interesting question. Is it a true discharge or is it pulling in?
That's exactly what it's both. And that's the point. It's completed. That's the point, right? It's pulling out a tendril somewhere else to hit the frigging tendril. But where are these tendrils coming from? Because it's in the air, right? When we're used to seeing them, it's coming out of the ground. We understand that makes sense because we know about the opposite charge energy in the ground when you're running a hot electricity, right? So okay, fine, that makes sense. But this is in the air. Where's it coming from, right? Well, it's coming from the air. It's coming from the potential of the air. It's inherently creating a charge separation.
So he must have created a field flip in that coil because of the cavitation. Here's the interesting thing. He had to have. There's no getting around it. So when I do my experiments with the cold energy, and then I put like on one side of the light bulb, I'll hook up the energy, right? Straight to it. It doesn't get brighter till you hook in the ground itself to it. So as soon as it does that, it's telling you it wants to pull the ground into the pump. Okay, that Tesla coil is the pump. It wants to pull it back to the pump. That's what it's telling you. So he had to have changed the energy in order to get it to pull like that. He had to flip it.
Well, I mean, look at a lightning bolt in itself. You're saying about cavitation. A lightning bolt in itself is a prime example of cavitation. It creates such a high energy differential in atmosphere as it's going to complete its circuit, so to speak, and discharge. But once it's discharged, you're left with a void. And that void, because it's in atmosphere and it's no longer stable, that automatically collapses. That's how you get the sound of lightning. It's the splitting of the atmosphere and the collapsing of it. And it's purely a cavitation effect of the atmosphere.
Yeah. So based on what we were talked about earlier, right? Plasmoid. Or how do you think it's built? I mean, you have to create an environment where the electricity's held in, right?
A charge, yeah. But call it a charge, but yeah.
So if we just told you static electricity is held in by the negative radiant energy, what happens when you amplify the fields and get it to a higher amount that'll be sustainable? All you're going to do is take your electricity that's in there, static electricity, and you're going to turn it into lightning. And then all you need to do is force the other side to hold it in. So you're literally going to get a lightning ball flying around. That's literally it, guys.
Star in a Jar is a great example of that. All they did was stabilize a cavitation bubble. If you could stabilize a cavitation bubble that's in a constant state of expansion and contraction, but it can't go anywhere because it's in multi-directional equilibrium, it's like I'm just a charge particle stuck in a bubble, and it lights up, and it's exactly what it is, and it's awesome.
But that's the thing, though, when you see them in the atmosphere, okay, so just understand this. You're not in a vacuum. You're not in that enclosed environment. That means that it has to be able to build those fields in the outdoor environment.
Yeah.
But that's why it's important to understand it the way I was trying to tell people earlier. There are two fields to be created. One is the energy inside. One is the field that holds it in on the outside. You're going to create a plasmoid. Now, how do they react to the environment? See, they go wherever the hell they want. There is no gravity on that thing. It literally darts wherever it wants.
Yeah, and it doesn't know any bounds either. It could go through things.
So if your charge is going everywhere where the positive end goes, it moves. Just like it told you. So that's all you're doing here. It really comes down to a basic understanding. If you can create that in the lab, you have it.
Right.
That's all you need.
One single spot where of the opposite charge, it's going to be attracted to it, and it's going to basically chase its tail at that point.
That's right.
You do away with the spot, and then next thing you know, it's stable and locked because it has nowhere to go. But you bring it back, and then all of a sudden it's doing whatever. Now, ironically, I would say that environmental factors could potentially of an opposite charge could play a role on that. So if you build a high enough energy density of the opposite charge, then all of a sudden, now you're looking at like a, three orbs disappearing an airplane sort of situation, where you're ionizing, the dielectric of the aircraft, and all of a sudden, you got like some instantaneous dematerialization going on.
If you created a high enough charge state on the outside of that plane, absolutely.
Sure. And,
because they're pointing the direction. And then once they all come together, of course, you're going to get a bigger field that opens up.
Well, think about the power density of that. It would create instantaneous cavitation with two opposite fields being attracted to each other and piling into each other instantaneously.
Well, that's millions of volts slamming into each other at a very fast rate.
Yeah.
And of course, they would go around each other because they're all looking to chase the tail, like you just said, right? Chase the tail. Get into the plot where.
Right. You don't even need multiple tails on each orb in that case. You just need one to have that charge, and next thing you know, the next one's going to chase it. The next one's going to chase it, and then you get an orbit at that point.
So if you tried to take down a plane, okay, with directed energy weapons, and your stuff was malfunctioning, you're going to put a huge charge on that aircraft. You're going to take all that aluminum, and it's going to sit there with its eddy current and force that charge right outside the aluminum, and then it's going to stay there. Okay? Now, it's going to have turbulence like a mother. You know what I mean?
Yeah.
But it's going to create the correct state in order to do it.
Now, what's interesting about it, though, is, right, I said dematerialized before, and that could happen, but when you have your independent plasmatic forces as the causal ionization of a secondary object, everything ought to be in resonance. And based on how scalar generally would work, I would say that event would actually, not necessarily dematerialize, but rather, like that's teleportation, man. Like we've talked about that before when we talked about Bearden and just, sucking all the energy out of a certain location. But if it's in resonance, it's not destroyed, right? If it's out of resonance, then it's dematerialized because there's no stability. So there's no choice other than to become entirely energy depleted, right? But if it's in resonance, then it could actually be entirely energy depleted, but then returned to where the hot end goes because the vacuum in the pump, right? And you collapse the wave function and goes back to where it came from or wherever you redirect it or capture it. Sort of how it goes, right? So, listen, man, that stuff is, it is what it is.
All you got to do.
It always feels really, really woo talking about it, but I tend to follow the logic and believe it. Well, I don't know.
All you're doing is bouncing frequency inside of one of those plasmoids. You're literally causing a state where it bounces the frequency all over the place. That's it. That's why some of this stuff's so important when you get into cavitation and learning how it works. So we're going to bounce the living daylights out of that frequency. That's why we want to use aluminum and not, say, copper or iron, right? Because we don't want it sucking into the metal. We want the faster you go, the more it stays off the metal, the more it hates the metal, the better it is. You know what I mean? That's why we want to use it. We don't want it to be into that metal at all. We want it to repel it as much as possible in order to create that state where that energy is forced to sit in there. Because this is like a capacitor with no volume limit. There's no amount that's too big for it. You know what I mean? Well, unless you fry the whole damn thing and it blows apart. But it's compressing, and it's looking to suck every bit of energy in that room to it. That's what it is. You see, when you look at everybody's experiments, you start to see things saturated and they move in an anti-gravity manner. If you look at Hutchinson, he is literally saturating that object until it loses its ability to stay on the ground. That's what he's doing. That's why he said sometimes it takes a couple hours, sometimes it takes 2 days. It's all about the point of saturation that thing can hold all that energy in order to move it. And he's filling it up with the radiant energy. Don't ever fool yourself on what you think he's doing. That's what he's putting in there. And he's moving it. You know what I mean?
Yeah.
It's just that. And
I
understand
wonder
that, you get
something
it.
real quick. Like all this talk is always bubbles and separation, and what like what I wonder is about like what happens if there was like a surfactant that was kind of like doped in a way to be in an equilibrium with water, so you could create literal thin membrane bubbles, but because the material of the membrane is in equilibrium, that if it's of a certain size, it would just become suspended in the water as opposed to accumulating at the surface. And then if that was in a separate chamber in a state of pressurization and depressurization, where it's in a constant form of expansion and contraction, if that would actually be a sustained form of atmosphere or cavitation. I don't know where I come up with this shit, bro. But it just seemed interesting, like thought. I don't know. I think that surfactant should be played with in terms of what you're doing, because if you run it through water and everything that you're doing, and then you add in a bubble to it, like an actual physical bubble, it'd be interesting to know if there's charge accumulation in those bubbles, even just regularly. And then if they pop, what happens?
Yeah.
That's
Well, if
sort
it
of
sprays it sideways, you got something, right?
right.
Well,
Might be able to tell you something.
Let's see. Like concentrated longitudinal waves. Yep. Ian's got it. Wow. You just can't please some people. Huh. Oh well.
Nope. Not there's some people that no matter what you show, no matter what you say, no matter what sense you make, whatever.
Brown's gas. I had some of that earlier.
Yeah, me too. It's good. Good. I made it to the bathroom in time though before I leave.
Instead of vice versa or something. Oh, I'm sure it says other comment. The fish in Japan. Oh. No, I just whatever. I know what it is. I've created it. I already know. So do with the information what you wish. I would ask you to experiment the way I did and find it. And you'll get it. Tesla got it. He already knew this stuff. Do you really think that Otis T. Carr built his invention without Tesla telling him the understanding of this stuff? I mean, think about it. I mean, it's the only way he's going to get it. So,
yeah. What I don't understand is like why we have people that constantly and continuously show up and are just like, I disagree. Like, listen, are you trying to convince us of something? Like, okay, that's cool. We'll have you on and we'll talk to you. Like, if that's the case, like, always willing to hear out another side, but like aren't you? If you just don't agree with anything that anybody's saying here, like, I mean, what kind of fucking naysaying asshole are you coming on, just sitting there wasting your fucking? You're not wasting my time. You're wasting your own hours and hours and hours of your time consuming material that you don't agree with. And for what cause? I find it hilarious. And what do you think you're doing? I don't know.
Here's the thing. You got people writing papers, though, that haven't seen the effects. You know what I mean? That's what drives me nuts about this. There's a lot of people that describe a lot of things, and they have no fucking idea what they are. They've never created it. They've never seen it. They don't know how it interacts, and they constantly tell you what it is, they haven't seen it. How do you know how it builds if you don't create something? Like, you can guess and you can see what everybody says, but if the consensus was right, my ass would be floating in the air right now, okay, talking to you on this thing. Okay? I'll be on my magic little fucking carpet and I'll be just doodling around going, look, motherfucker, I can fly, right? But the consensus is wrong. They missed something. That's why it's important to go back to it and look at it and say, okay, what the hell did they miss? Why is it that they missed something? What did they not look at? Are they following the right people? Did they look at the right experiments? Did they recreate the experiments? Did they find out, hey, when I ran across the anomaly, did I run it down? Did I find out where it came from? Did I find out why it worked? That's the whole point. A lot of these anomalies is exactly what Tesla worked on. He would find one, exploit it, and come up with something brilliant. And people said, well, he pulled it out of his ass. No, he did the experiments, and he found the anomalies and then just absolutely drove them into the ground and, trying to find out exactly what they were doing. So that's where you got to look. People like that, not people that hit something. Because even when he went back to like Hertz and he starts talking to him about, hey, this experiment was this or that, I couldn't find it. How did you find it? Show it to me. I mean, talk about somebody that's, would find you and hound you until you gave him the right answer. That sounded like him.
Yeah. No, it's all good stuff. I don't want anybody to think that we don't keep an open ears and an open mind. We're literally a fringe think tank of individuals, guys working on stuff, guys thinking about stuff. It just is what it is. Shutting out ideas is the worst possible thing that you could possibly do, but there's got to be substance to the ideas too, or else then we don't really have a lot to work with and discussion, but for what it's worth, I mean, this is as much, and I've said this from the time I've come on the show, at least, because I don't do experiments. See, Nathan's showing guys work. He's showing you what he's actually getting, and you could take that for what it's worth. And to me, that's worth a lot because results speak louder than any sort of idea that you have. But you got to remember, nothing that we're talking about is scientifically proven, period, at all. It's not accepted by mainstream science. It's not true, and it's certainly not untrue. There's things that we talk about that are observable consistently through not only the theory end of things, but also on the observable experimental end of things. And one has continuously coincided with the other, so if anything that we're saying is super far off base, hey, listen, point out, don't be cryptic about it. Say, hey, look, this is actually the way I think it is. You ought to take a look at this, because there's one thing I'll tell you is that if you make sense in what you're saying and you're actually putting it out there and not being cryptic, reading between the lines about it, there's nothing anybody here won't try, in order to see what's what, to find another or better way. Because, I mean, for Christ's sakes, I mean, the old man's sticking wires in burritos to show his point. There's nothing he won't do. He literally put the energy through dozens of different media to see what works and what doesn't. That was all based off of the recommendations of the viewers. He listens and he does, and don't want to shut anybody out. But again, if you just simply don't agree with the fundamentals of everything everyone's saying here, I mean, you got to think to yourself, whose time are you wasting at this point? If it's not going to be productive conversation. That's all.
Yeah. Well, look, there's a lot of good points out there. And I read through all the PDFs, okay? And I put out the information and let people decide on their own. We did the one today with the anti-gravity stuff, the Byfield-Brown effect. So that's out there if you want to listen to the whole thing without our commentary, go right ahead. I also put out, what's that guy's name? Kozel.
Oh, Kozel, yeah.
Yeah, so that if you guys want to understand the Kozel sphere, and I also put out Linderman in case you wanted to hear his things out of his book. Look, it's all important, but they're all telling you the same thing. And at some point you got to realize it. They all told you the same thing. And you just have to understand it for what they're saying. There's only so many types of energy out there, and you got to find every one of them in order to make them work together. That's why I put them out there all together. It was like, okay, he said this, right? And I think Linderman's absolutely super intelligent, by the way. He put it out there like this. He said Tesla did it like this, right? And then you go over and you go, okay, Kozel's telling you about this, but it's all the same energy. But they did their experiment. They had no idea what the radiant energy was. And then you turn around and look at Dollard. Dollard does the same thing. He's doing all the Tesla experiments piece by piece by piece by piece. And they're all saying the same thing. That's where I'm going with it. They're all right in line with each other. If you found that last part of energy, if you didn't, none of it makes sense. It won't fall together. It doesn't make sense at all. Like you'll get lost in the outside of a Tesla coil and you'll never find it. So it's just interesting. Yeah. By the way, my favorite was the grapes. By the way, you could take 20 burritos and still light up that Tesla coil. As a matter of fact, I can light 2 of them up at the other end of that. Those things are insane. So that outside tortilla, even when you put it in the microwave, that's like the last thing to warm up. Everything in the inside burning hot, your tortilla's cold. Like, it's just strange how it all works. So, yeah, your tortilla is hard as a rock, too, unless you put water in there with it, which, by the way, is an interesting thing. So.
Yes, it is. I want to throw something out there about Tesla 369.
Oh, go for it.
Topic, but it's just, again, it's always just food for thought to put your head around this. Now, if you want to talk about, like, for instance, potential, okay, energy and matter, okay, let's say that's 3. Now, let's say each one of these, okay, has 2 interactive points, all right? When you look at the 2 interactive points, it's 6. Okay. Now, where these 2 interactive points then meet each other, okay, that in itself equals 9. All right. And that's the basis of everything, is these 3 parts with 2 sides of the coin, each and how they interact with each other at these other 3 points. Right. So it goes above just potential energy and matter. It goes with every different type of manifest of energy and so on that exists, and it's omnipresent. You'll always find it in these bundles of 3. 3 with 2 parts each being 6, and then all together is 9. So I just want to kind of throw that out there too. It's directly correlated with vibration, energy and frequency, and they're 2 sides of the coin and their interactive planes. So that's just something that's food for thought, that I just wanted to kind of put out there, because I know that that's something that people have brought up a million times, and I think it's more gimmicky saying than anything else, but it is present time and time again. So,
well, think about it this way. When you build out in each key, when you're in a music scale, it goes 3 plus 3 is 6, right? But then you have to take the 6 and go back to the original number, which is 3, and add that. It comes out to 9. It's scaling it the proper way, just like a music frequency. That's all it's doing. It's scaling the octave the correct way. So that's what's interesting about it. So would it be a 12 after that? Then, you know what I mean? So on and so forth. So you don't double it. That's what I think a lot of people say, and I probably said it in the past a long time ago, but it's not. It's the original number is added to it again.
It follows the Fibonacci sequence is what it does. Mm-hmm. Because if it were 3369, then you would realize that to be the case. But, the duplicate being irrelevant, right? So it's just 369 and follows the Fibonacci sequence. Right? And did Tesla ever say it? I mean, not that I ever read. but I think that it was a good descriptive way to say a lot of things all at once and have it not be all too apparent what he means by it. And that's why I'm shedding light to it, because it is relevant to his other writings. Whether or not he ever said it, not in anything I had ever read of his directly. Obviously, it's just well out there that is something that he kind of preached, and he certainly did in his own writings have, you know, quite an affinity for the number 3 and anything root 3. So that I know is present. You know, he had all sorts of quirks and stuff like that about him, and that was one of them. So it wouldn't be shocking if that was something that he did say or preach, you know, maybe just not write down specifically. Could have been in the trunks.
Well, think about it this way: he does the ring, which is just one octave to the next, to the next, to the next, right? And that's exactly the way that ring builds out. As soon as I look for radio frequency in a Tesla coil, I see it all day long. You know, you could set your watch by it if you want. It's really that simple. So he knew it. There's no way he didn't know it. You can't be that smart and not know it, especially when he sees it every day. But then again, he didn't. Did they have an oscilloscope back then? I don't think they did. Everything rings by, what did he hang from the ceiling? I can't remember what the hell he did. But he did something to find resonance in there. And everything he knew what was resonating with it, which is even cooler. Like, how the hell do I hang something from my ceiling and get it to resonate? That's what I want to know.
So somebody said something in one of our videos that was a comment the other day that I found interesting. And they kind of touche'd us a little bit because
go for it.
We were saying how there's really no effective device readily available to measure something's resonant frequency, you know, and they're like, well, isn't that like a guitar tuner? It's like, touche, you asshole. No, totally dead on. That's absolutely true. But I think what was sort of more implied is that, I mean, that's of a tuned instrument, right? In that case, or something tuned, something capable of having a steady frequency, you know, and being able to be also adjusted as well, you know, and obviously that's key. The thing is that it's under tension, right? Or some type of consistent form of vibration that's occurred. When you're talking just about a solid object, I mean, you could hit it and then hit it again in a different spot and just get a totally different tone based on where you hit it at the time. So, you know, but what's the overall resonance of an object, let's just say? I think that's more what we were kind of trying to allude to. And as far as I know, nothing like that exists. Like, you know, and if it was, it would be something more interesting than a guitar tuner necessarily. Like, it would be sort of like something that detects like earthquakes. You know how they could detect earthquakes at like a distance out of like a very fine, you know, rumble. It would be almost like a scale in the sense that you could put an object on it and it's able to weed out all the ambient resonance and then just focus on what the resonance of that particular thing sitting on it is. Like that as far as I know, it doesn't exist. So, you know, I just wanted to throw that out there because we did get touche'd and I loved the response because it was witty as hell and absolutely true. Absolutely true. You know, it's a good deal. Man, we got great viewers, you know that.
Yeah. Well, Sean says that he takes his oscilloscope and he scrolls through it until he finds the resonance frequency. The highest peak is available when he hits it. So,
but hold on 1 second. But again, that's a tunable system under some sort of tension. It's got a path, okay, and it's got a current putting it under tension. So
you're right.
That's the same exact circumstance. What happens when you just have something that's not in that circumstance of being under tension?
I guess that's true.
Yeah. So, but that's a great point, right? For what the stuff you're working on, that's perfectly true. But let's say it's an object that you want to find the resonant frequency of. There's just no accurate, realistic way to just get that, because it's not under tension.
Yeah, well, you got to get it to make frequency. So anything that would have energy to it, you can find resonance of. But what if it's not anything that that has that? Yeah.
Sounds like a math equation now that I'm bubbling with it in my head. You could probably run current through the damn thing, or a frequency through the thing, and based on some kind of calculations, come up with a figure. But I don't know what those numbers are, man. I don't get paid for this shit.
Well, Ian brought up capacitors, voltage increase and decrease. So that's an interesting question. Can you set your capacitor to the frequency? And usually we use frequency to change the capacitance. So I'm sure there's an answer there, and I'm sure somebody has. It's just trying to think of an example of where I've seen it. I mean,
Two sides of every coin.
yeah, I mean, we use the cap bank in order to do it. I can stick things down the Tesla coil to change the frequency of it. I removed wire from a Tesla coil, which almost brought me to tears. I hate undoing my work. But yeah, I did that to do frequency. I don't know. You
I'm
would, you know
playing
what?
with that one too.
Hold on. So if you took the Tesla coil and you ran just a number 2 coil only, and you had to gauge how much capacitance was in it, because it would be in reverse, it's got to be in order to pull out the energy, right? It's got to share that same capacitance completely in the circuit. I guess it'd be the same thing. I don't know if that's reverse though, but in order to pull the energy out, you'd have to do it. You know what I mean? Like, I don't know. All right, I'm gonna have to find out. I'm gonna say,
We're gonna have to think about that one.
yeah, because you got to get
right
it
off the
reversed.
bat. Like I'm just sitting there saying to myself, like, in order for it to happen, there's got to be rectification that occurs. So it would have to be something on discharge. It wouldn't like. I know it's silly, and I could be very, very wrong. So I'll eat my words if I have to. But I think it's the wrong question.
Okay,
it's
go
less to
ahead.
do with the capacitor and more to do with the capacitance discharge.
How fast it discharges.
Yeah, the capacitor discharge.
Oh,
You
okay.
follow? It's the wrong question, I think.
Yeah, because the capacitor, if they're the wrong capacitors, they're not fast enough. You find that out with your Tesla coil. Even if it's the right value, it's the wrong frequency that's available to go through it. Yeah, okay.
Yeah, all right.
No, I've had that problem.
Yeah. Yeah,
Yep.
trust me. Like I spent my whole entire life asking the wrong freaking question, and I've gotten pretty decent at identifying it.
I bought once, I should say more than once, a Chinese little board for running your Tesla coil. Because back then I didn't know nothing about them. So I go and buy this thing, but I wrap my coils wrong. So one wraps to the right, and then my primary is wrapping to the left. And it still gave off a little bit of spark, right? And I'm going, man, this thing sucks. It really doesn't do a whole lot. The whole time it's my fault. Okay. You got to wrap them in the same direction. And I didn't do that. So I think I blew through 2 of those. And I thought, well, it's about time I learned something about this, because that was $50 a pop. So I fried it and found out twice. And then I
it
learned
gets
my
costly.
lesson.
Trial and error is expensive,
You should
especially when
see
you're wrong.
my ZVS collection. Oh my God, I fried everything and found out. Let me tell you that. At what, $40 a pop, somewhere around there with delivery? You know what I mean? 10, 15 of them are sitting over there in the junk bin, because every time I tried to manipulate the energy or force energy to discharge faster, like Tesla Dynamo would do to it, I couldn't get it right. Well, now that Jarvis is going over it, I found out what I was doing wrong. And number one was using a transistor to work on it, because they immediately blow up. So that was number one. Number two is you wanted the dynamo so you could have a steady energy source at 60 hertz, which is just simply pulsing this thing and running it in there, and then that number 2 coil itself pulls off the resonance. It goes right in there, and then, like Tessa said, you shove the rod down the center, you change the frequency, you also back up the energy into it, and then you let it out, and man, it just fires. So, yeah, the things I was doing,
I mean,
wrong stuff.
Ian, because he's brilliant, he's always clarifying. So even the secondary discharge doesn't align with the maximum capacitor fill up. I mean, I'll let you tackle that one, but to me, the first thing that comes to mind is just efficiency. There's efficiency offsets that occur that wouldn't have them aligned because there's neither the secondary discharge or what's being captured by the capacitor is in a pure state of equilibrium. I mean, that's just what comes to mind for me, but what the fuck do I know, man?
Well, we just talked about it. You just increased the octaves as you went up. So the frequency went up. Right?
Oh, right.
It wouldn't match that at all.
Ways, right.
It would never match. As a matter of fact, if it matched, you better throw away that coil or start over because you got a problem.
Well, it could match, but it's a math equation, right? We've tackled that about was it like taper gauge wire and coil geometry that would ultimately probably maintain resonance, but
if it's geometry coil versus a Tesla coil, because the Tesla coil is going to ring it, no matter what.
Yeah, right. It would have to be a geometry coil with a taper gauge windings. It becomes a math equation to maintain the native frequency input on the discharge.
So, setting up a second coil in order to get the resonance out of it, you would have to use a spark gap. You cannot use a capacitor right away. If you do, you're only going to get a quarter of the energy. So that just hit me right there. I'm sorry. You need a spark gap. And because it comes out as a bipolar Tesla coil, with the way the energy goes in, there's a null zone in the center, bipolar, the two sides go together. You need basically a screwdriver that comes in there and picks up both sides like this. And then you have it, right? And then you pull it straight out, put it into whatever you want. You broke the symmetry of it, and the frequency is good to go. So, yeah, Sean's coil types. I can only imagine. I should build one of those. I keep saying that. Those things are monsters. I know Ian's got a bunch of them now.
I think the juice is worth the squeeze on them, man.
Yeah.
I think the juice is worth the squeeze on them. And I think that there's ways of winding what he's doing that would, and I've kind of discussed this with him, but I'm not really sure if he really understood where I was going with it. There's ways of counter winding them and such where they're out of phase and stuff that would create crazy field effects, really, really crazy differential field effects.
So we just talked about that on Monday. We were just talking about the Meg, and he had created a ringer. So counter wind going to a cone on the top, then counter it on the bottom, 180 degrees out of phase on the bottom, and then he sticks a magnet in between the two, and it acts like the Meg, but it's a ringer.
So what I was talking to him about was in the cone, I think it was a good example, right? He had the cone, and on either side of the cone, he's got channels, right? And I said, if you took two windings, started them just offset of each other, but then had them crisscross, where they basically just crossed over each other at that point, and then reversed in direction, crisscross reversed in direction. And then he calculated it properly that when you start the bottom reversal, you could go back up the thing the other way. You'd have massive, cancellation, right? But you'd also have major compression on those interaction points, and whatever the central flow of it is, you'd have major compression of it, scary with what he gets out of it. If you were to have it in tune where it's not really discharging a whole bunch, because it shouldn't, I think it would be scary. Be able to stick a wire in that.
So are you braiding it at that point?
It's sort of a braid. It would be where the channels come they both go up, but then back around. So so one wire, it would be so complicated to have to get it started. But once you get started, it's not that bad because it would have to work off of, you'd have to start at the center and offset and basically have it so it crisscrosses at the level and then return back and then crisscross and return back like that.
So it's like a half basket weave, half like braid. It's a
right.
Even,
And then from there, once you get to the top, you wind it top up and then down and then up and then down, and it would be alternating. So you'd have, on one side, call it side A, then the other side B, right? Then next level down would be switched. Next level down would be switched. Now, when you get to the top, instead of it being A, B, it would be, B, A, and then switch and do it until you get all your windings in. And I just, I really didn't have a great way of articulating that over text. I was like trying my best, but I'm interested in it. I'd love to know.
Okay, I got a picture for you, Joe. Tell me what this looks like. Sorry, give me a second. Now that's carved in stone, so that's not something I created. What does that look like?
A couple of things I could think of.
Go ahead.
Looks like a bat. Looks like a vagina. Looks like an atom.
Maybe I shouldn't have asked you. Maybe I should have told.
Looks like a waveform.
Wow. I should have known better.
Well, I mean, listen, you know what you're asking.
Can't
unsee
it. What it reminded me of was that Kozel device I'm working on. It's got.
Of course, that's the first thing that comes to mind. I see the sphere within a sphere within a sphere with the center pole running down the middle. I mean, still looks like a vagina. Not a great one or anything, but
all right, let's take down that picture before we throw it off the air. Wow, that was a mistake on my part. Okay, let's try a different one. Maybe this time I'll put out something instead. Never give Joe those little blotches to look at and tell you what it says.
I mean, I said a bat before I said the P word. What am I going to tell you?
Oh, so this is like, how do I say it? T.T. Brown in his capacitance in there. So does this remind you of anything I was describing before? And not the inappropriate stuff?
Does this look like anything that we talked about before? Well, we weren't talking about communist housing.
No.
So that rules that one out. I mean, I could think of tons of stuff that we talk about all the time that it looks like. But nothing that comes to mind that we were just talking about.
Okay. Fields inside of fields, scalar fields, trapping in static electricity, one on top of the other, creating.
Okay.
You know what I mean?
Yeah.
Creating the stack.
I could see that. That's fair. Still looks like a commie block, but whatever. They might have been a little more
Like
square. They didn't really go
apartment
around
building to me, so I guess it's a matter of perspective.
What did it look like, Ben? Say that again.
It looks
Parking
like
lot?
a capitalist apartment building to me, but I guess it's a matter of perspective.
I suppose. Nah, we don't build stuff that nice anymore.
No, you're right. We don't.
So I was looking to the left over here where it showed the rod and the energy going in and how it went to each single layer individually, which I'm sure they had their own frequency. You know what I mean?
Are those magnets?
I to be honest with you, I don't know what the experiment is. I just saw the picture and it looked like something that we were talking about, so I wanted to bring it up.
It didn't come with no papers or nothing.
No, no papers on this one.
Damn. Yeah, it looks like magnets to me, honestly.
Looks like a hard drive, man.
Yeah, that too.
Like, I mean, a really convoluted,
thick
very
one.
small hard drive, but
But it's layered the same way.
yeah, it's layered the same way. Really, what came to mind for me out of the stuff we talk about is like cells mostly, like any sort of energy cell, or which another form of that being like orgonite cells,
Like
things
a
like that.
variable capacitor.
Variable capacitor, yeah. There you go.
Somebody said motor core, field generator, adjustable capacitor.
Right, it's literally the geometry of everything.
Yeah. We got a
Like,
wow.
I don't know what I'm looking at, but it looks familiar. I don't know.
What was there a label for this?
No, there's no label. Look, it was just I want to throw it out there as a thought thing because we're talking about always layer, always cavitation, always the static, always the what I mean?
Well,
The
that
scalar
right
field.
there on the left hand side, that's an AC symbol, right?
Yeah.
So
Okay,
that must
let
be
me
like an AC
hold on.
input.
I don't think you're getting the spirit of the conversation. We're not trying to figure out what the hell it was. I'm trying to figure out, does it remind you of stuff we talk about? I could care less what it was. It wouldn't be that if it was in my garage, that's for sure. There you go. Sean's layers in his Tesla coils. Yeah, it looked kind of like that too. Put a big rod down the center. Yep. As long as it's not the previous picture Joe was talking about, I think we'd be okay. Oh. It's okay. Don't ask Joe those questions and don't ask Gerald to draw a circuit. We'll be all right. Remember those simple rules.
Bipolar Ulysses, yeah, most of them are.
Yeah. Bifilar too. You know what I mean? I got to figure some of those.
Well, you know what the
Bipolar.
solution for that is, right?
What's that?
Lithium.
I just walk right into it.
Yes, you did.
Oh, wow. The things we talk about on this channel. Oh. Yeah, I just thought it was interesting, man. When we start talking about this stuff, it's always fun. Like, there's so much stuff out there on this stuff. And, you know what I mean? If we could just get everybody on the same page building the same thing, man, we'd have this thing done in no time. And by the way, I have seen it made in other devices. Gell's geometry coil makes it. You know what I mean? My Tesla coil makes the energy. We see it in the Rodin coil. And if we just added, you know what I mean, another little coil to it, it'd be perfect.
Mhm.
Because it literally tells you the energy flow by its design, which is just, I think is really cool.
Well, I mean, the energy flow in a Rodin coil in itself is a beautiful thing to witness. So, I was always a proponent of I want to see multiple offset, counterwound Ronin coils in each other because I have reasons for that.
Yeah, I don't know how that. Well, I guess if you wind the first one, put it in the center, and then wind the second one, yeah, it'll work.
Yeah. Yep.
Trying to think about how I had to wind this thing with that big old needle Ben invented. That you should have seen me, man. This thing was like this long, and I feel like I'm sewing through the hole every time.
Yeah. If you took two Ronin coils one inside the other, but then had them nicely and geometrically wound, maybe you'd be onto something. Yeah, I think.
What do you think, Ben?
Yeah, it could be something. I mean, we already know that the pickup from the coils is a lot, so it's picking up a lot of energy from the primary coil. just as a pickup. So if they were wound together, I could imagine it would probably amplify it too.
I'd imagine that the field flow would be very, very intense, externally and internally.
You created greater density in there. Is that what you're saying?
I think so.
And you say counterwound to each other.
Down around, yeah. One way on the inside, the other way on the outside, and
So a single wind on the outside instead of a turn back on itself winding.
Yeah, there you go.
Single wind, and then the inside's a single wind. But they're counterwound to each other. Like, okay, now I get it. Okay,
Yeah. Geometrically,
perfect sense. They're
exactly, and then geometrically and out of phase. Yeah. So same flow pattern, right? Same flow pattern, just a different route, right?
You're looking for a time dilation, aren't you?
Of course I
Do
am.
that.
Right,
I
that's
mean-
what I'm talking about.
Gotcha.
Mhm.
But no touching each other.
No,
What's the distance between them? Like a half inch or something?
I mean, it would probably have to be to a ratio that is to do with the overall geometry. The inner coil and the outer coil would have to be in correct ratio with one another, probably to the same ratio as like the thunderstorm generator, same ratio as that you're probably building in the ball machine, right? Same ratio. Yep. That's what I believe.
Normally, I'll say it. If you take the volume of the sphere and then we found the number to it, and then we did it in octaves, I would have to take the original number and add it to the next one, right? And then that's the second sphere. And then again, it's just like we were talking about building out frequency. That's how it builds it out, right? One after the other. Yeah. Okay, I get it.
Yep. So where is Gerald anyway?
I don't know. Last week he hit me up and said he was working late again. So I know he's working hard.
I mean, look, I know you said what was going on with him, and I'm just hoping something that he can, power through, get back on, because we all miss him.
Oh, we definitely miss him. I can't wait for him to come over here and just break through everything.
One day.
Yeah. So, yeah, hopefully he comes back soon. And then Sean, by the way, I had to go to the VA hospital and take care of some business. So he was out today. So, yeah, I hope he's all right, man, and everything's going well with him as well. So hopefully he'll be back next week. And, you know what I mean? Dazzles with his Tesla coils and all his voltages, because those are bitching.
Yeah, for sure. When I heard he wasn't going to be here today, I wanted to make sure that, I bothered everybody. And so hopefully he is back, next week for everybody's sake and sanity.
Well, you definitely gave us some food for thought, Joe.
Yeah, something.
Huh. Ben.
You said what? No, I don't have my headset on, so it's hard for me to hear.
I want
My
you to check
headset
this out.
died.
So I haven't
Sometimes-
posted the thing on there. I just want to show you.
I saw that in the background. Did you get the light bulb working?
I didn't even start it up yet, man. I just barely opened it
Oh, you
today.
just opened it? That's nice.
Ooh,
It's,
Nathan, that looks pretty.
Yeah, it's a
Yeah.
different color than mine. It's a lighter green. Looks like.
So it's a bifilar coil, and it's what's the circuit, Ben?
So that's a modified Joule Thief circuit. Basically the same thing that's in the Lightning Thief. It is utilizing a different pot and resistor though. It has a neon bulb in there for protection. It's utilizing an MJ21194G transistor. It's utilizing that might be the fusion coil. Yeah, that's the fusion coil that's attached, but the coils are swappable. And it should have come with I think a 5-watt LED light bulb attachment.
Yes.
Yeah. Yeah, so
Yeah.
it's a remarkably beautiful night lamp. We will be everything's open source if you want to 3D print, one out and stuff like that, but we will be providing them, on my shop very soon as well.
Let me know when one's up there. I want one, Ben.
I'm gonna try to put together some for the team. I'm gonna try to send some out to you guys. Because Michelle sent one out to Nathan, and I was like, look, I think all the team should have one. So I'm gonna, as soon as I get the printer back working, I'm gonna try to print some out for you guys. And I don't know, did you want me to send them out like as kits to assemble, or did you want me to send them out pre-assembled? Like, it's really up to you guys.
Yeah, we can talk about that on the side, and take care of you for it and everything.
Yeah, because it's it's some of it can be a little complicated, but it's it's not that hard to put together. And then the coils, there's a certain method to hooking each of them up, because it comes with all four bifilar inputs. So you got the start and end to channel A and the start and end to channel B, and I believe the start of A and the end of B are connected on the PCB. So it's utilizing an open circuit method where it's connecting two and maximizing the resonance cavity. Yep, there we go. Is that the screw? Oh, that's the new fitting.
Look at the wire. It's woven.
Yeah.
One into the next.
Yep. It's
So it
crossing.
starts here, goes to the next one, then goes to this one. You know what I mean? Back and forth, back and forth. Sorry, big fingers. So if it's on the top here, it goes to the bottom here and the top. You know what I mean?
Mhm.
All the way throughout it. And it's the exact same distance, both wires.
Yeah, it's crossing at multiple points. So you got multiple angles of intersections between the two wires there. And it's weaved perfectly. He said spend your time when you're making these coils, because you want it like that with a little bit of space in between them. You don't want it all crushed together. If that makes any sense.
Yeah, not exactly what you're talking about.
Beautiful
though.
work. Really, really, really nice.
It is. Yeah, no, I'm gonna start my work on mine. As soon as I get the printer back up and I start printing some more components, I'll make another coil and start, doing that. But I don't know, maybe we'll have a workshop for it.
Very good, man. I love what you're doing.
Yeah. Dude, that stuff's so cool, Ben. I'm excited to put it, you know what I mean?
Yeah,
he got it up and running
for you too. The American fitting. I have the European one, so I have to print out a new base. But he also had adapted a cover for it, so it's not as like exposed the circuit. So that cover that's on top. So that's like some new quick adaptations to the setup that were kind of like last minute that he introduced. That I don't know. I think they work. We want to expand the base a little bit, though.
Well, if you take the circuit and move it to the side a little bit, you can almost make it look like a Chevrolet engine.
Mm-hmm. Well,
you know what I mean?
Yeah, what I wanted to do is use Sean's idea of using the copper tubes, right, and implementing those in some way to make it look more steampunk.
Yeah, look at that right there. That's like a LS1. If you do it right, you put your Corvette valve covers right here on the side.
Yeah, that would look. Yeah,
you can pull that off pretty easy on there.
And then just so you know, the transistor is pretty easily swappable. So if you wanted to try something else, I tried a couple of different ones. I'm actually currently using the MJE 13009 on it.
That's Gerald's what he uses, right?
Yes, that's the one that he recommended. But I've also tried a MOSFET on it, and it didn't like work all the way, but it was blinking. It was really weird. I've never seen anything like it. It was like the neon light was blinking, so that was weird. I wonder what it means. I tried to ask Michelle, but I don't think he knew.
Yeah, well, we're gonna have to dig into this a little bit. I'll probably do a video on it, Ben, when I fire it up the first time. You know what I mean?
Yeah.
I think that's pretty cool. I kind of want to.
Oh, just real quick, if you put a diode on the positive going from the positive terminal to the light bulb, put a diode like a I have a what is it, a 4007. If you have that pointing towards the light bulb, it seems to improve the efficiency a little bit.
What is that? Like 100-volt 100-volt diode?
It's like just like a high speed diode. What is mine? Like an NF4007, something like that. Hold on. What are these? UF4007. So
Okay.
it's just a high speed diode. You put it on the positive rail pointing towards the light bulb just to make sure some of that back EMF isn't leaked back towards the positive terminal, I guess. Because the way I like to put it, like analogy wise, is like, if you don't have the exact proper capacitance for your light bulb, it's like you're sending water from a pipe into a smaller pipe, and some of it's getting rejected back, and you want to use that diode to catch that extra that's getting, and then redirect it back towards the light. So that's what I've experienced, at least in my Lightning Thief system. It's basically the same circuit. So
Cool. The diode, let's see, UF14007, Ben, is that what you said?
UF4007. Yeah, it's a pretty common one.
Okay, so hold on, I pulled it up. UF14007 is the rating of 1000 volts and 1 amp.
Yeah. Yep. I see it on the package here. 1000 volts, 1 amp. Yep.
Cool. So right on, man. Right on. That's going to be pretty cool.
Yeah. One quick thing though. Michelle did note that try to keep it below 500 milliamps. When you're adjusting the pot, I would hook up a multimeter to see what the current draw is, and see if you're like where that 500 milliamp limit is. Because he said that if you keep it on 500 or above, the potentiometer might burn out. So, I'm sure there's, you can find a workaround, or, what I do is I just, measured it and I found, it's, about like 6 o'clock is my limit, on the potentiometer dial.
Really?
Yeah. Yeah. And it'll vary depending on the transistor, because the transistor changes the frequency range. But as soon as you turn it on, you'll hear it. You'll hear it, even if it's not, the light bulb's not on, you should hear it.
He said,
So,
what is a diode? Sorry. One-way direction. That's it. But it also takes a little bit of energy to run them through. There's a little tiny bit of resistance in there.
Yeah.
But it creates one-way direction of energy, so it doesn't allow the energy to go back on it. So no back EMF or anything will be allowed through it. That's what the diode is.
Yeah. And then honestly, I'm now that I'm thinking about it, that's probably what blew out the PCBs that I was working with earlier. Remember I said I blew out the positive line? Is because I switched up the positive and the negative on the load output, and the positive, the negative was going back into the positive terminal, and it blew out the whole PCB line. It was just so much for it.
Well, that happens. If you, I don't think you can get to that one, but if you had a ZVS and you needed to fix it, you basically take a wire, strip it bare, put it on there, solder it on both sides, and it'll clear the distance, and you'll be able to fix it.
Just get that line back. Oh, yeah. I didn't throw them out or anything. I'll keep them just in case.
If you can get to it, yeah. If they haven't buried it inside the board.
Yeah. They're pretty big boards, to be honest. The one that you have for the Lumen lamp is a little bit smaller than the Lightning Thief. So, yeah, it's a pretty big board. It's, pretty easy to get to all the components. I think it would be repairable, honestly. It's not, it's just honestly one clear line, and it's not really obstructed at all. So,
well, you can always hotwire it, Ben.
Yeah. So
You know where it goes, so just run a wire from there to the other one and solder it in.
it was loud though. Like it was a loud crack. You know, like as soon as it blew up the fucking PCB.
You're running it back onto itself, man. Of course, it's going to be a loud crack.
That's why I said I thought I hooked it up backwards, and I'm like, I think I did. I think that's what I did because now that I'm seeing, that there is a lot of extra back EMF that is getting back towards back through the positive, just with the light bulb, attaching the diode, and it doubled the brightness. So that kind of just, that observation proves it.
Yeah, that's so funny.
Yeah.
And frying it and finding out, even though he doesn't want to.
Yeah, I destroyed a couple of good PCBs. Man, I spent a long time on those, putting the screw terminals on and all that stuff. But we're going to do a live stream where I'll walk everybody through how to do it. And when I send out the prototypes, you guys will have an extra board to mess with. So
nice.
In case I fuck it up.
Nice. You never know. You gonna test all of them before you send them out, Ben? Throw them on your machine there.
Yeah, no, I'll test all of them, and it might take me a little bit longer than I originally thought, but I'll get them out to you guys. It's just gonna take a little bit longer.
Right on, man. Yeah, really cool, man. I got to get on there and say thank you to him for hooking me up. So
yeah, he really hooked us up with these lumen lamps. They're amazing. And I can't wait to honestly, like, I have fun building them. So I can't wait to build more and send more out to, you, Joe, and everybody else. Ian and Sean is going to get one. Actually, I don't know. I think Michelle sent 2 out. He might have sent one out to somebody else already, but I'll find out who he sent one out to so I can, fill the rest of the team up with lumen lamps.
Right on. All right, man. It's been like 2.5 hours plus. It's about that time, guys.
Yeah, that's awesome, Ben, man. Yeah, keep it up, and let me know about that because that thing's looking beautiful.
It is. It's a nice little night light.
Yeah, I think Joe might be over there putting his one of your little baby rodent coils on it. You know what I mean? Yeah, don't ever put it past him.
We hooked up the I hooked up the micro vortex coil, the one that fits in the palm of my hand, and we got it to light the bulb very, very like briefly. So there is a small range there. I just, I haven't had time to mess with it further, but it'll work. It'll work, definitely. Totally work. You can hook up any kind of bifilar coil to that, and it should work as long as it's within the size for the potentiometer and the resistance. If it's not the right size, you might have to adjust that. So.
Yeah, you may have to build one of those small little rodent coils for Joe as well.
Well, that's the plan. I plan on building a lot of the small ones and then selling them. So, so hopefully we get a whole big stock, and I'll be able to provide everybody with some, and some testing equipment, some rudimentary stuff.
Right on. All right, guys. Look, it's been an awesome show. Joe, thank you for coming in and helping us out today, man, and going over this stuff.
Yeah, man. It's fun as always. And, I know Sean's always a tough act to follow. So,
He is.
You gotta have a good show, in lieu of that. So I'm thank you for having me.
Yeah, right on. I appreciate you coming in, man. Awesome as always. Awesome. Ben, thank you.
Of course.
Yeah, we're going to get these things going. We may have to do, like I said, I'll put out a video on this thing once I get the time out here to do it. And we'll get this thing rolling. So, right on, guys.
Good. Well, God bless you and your vagina carvings, Nathan. Amen.
Oh, Jesus. Just had to do it, didn't you?
Yes. I use proper terminology.
Proper terminology.
Scientific words.
All right, guys, it's been a great show. Thank you very much. Thank you, chat. You guys have been awesome tonight. Have a great night.
Peace and love, everybody.